which held online on October 20th, 2021 in Semarang, Indonesia.
Ladies and gentlemen, at this year's conference, we will discuss about our theme, Bridge Towards Industrial Revolution 4.0 and its application on electrical, electronics, computer science, and informatics for humanity. The conference is hosted by Universitas Islam Sultan Agung Semarang and organized with Universitas Diponegoro, Universitas Sriwijaya, Universitas Ahmad Dahlan, Universitas Budi Luhur, Universitas Muhammadiyah Malang, University Teknologi Malaysia, Tati College Malaysia, and IAES Indonesia section. The event is intended to provide technical forum and research discussion related to advanced engineering on electrical and electronics, computer science, and informatics.
Ladies and gentlemen, without further ado, we would like to invite Bapak Ali Mustafa to deliver Al-Quran recitation. Please welcome.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. كنتم خير أمة أخرجت للناس تأمرون بالمعروف وتنهون عن المنكر تأمرون بالمعروف وتنهون عن المنكر وتؤمنون بالله ولو آمن أهل الكتاب لكان خيرا لهم ولو آمن أهل الكتاب لكان خيرا لهم منهم المؤمنون منهم المؤمنون وأكثرهم الفاسقون صدق الله العظيم. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Bapak Ali Mustafa. Ladies and gentlemen, may the Al-Quran recitation makes our soul fully charged spiritually, and may Allah bless this fruitful privilege. Amen.
Ladies and gentlemen, we would like to proceed this conference by singing the national anthem of the Republic of Indonesia. Please stand up. Thank you, and kindly be seated.
Ladies and gentlemen, now we would like to invite Chairman of EECSI 2021, Dr. Arif Marwanto, to give report and welcoming speech. Ladies and gentlemen, please welcome Dr. Arif Marwanto.
Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. In the name of Allah, the most beneficent, the most merciful. Welcome to the 2021 8th International Conference on Electrical Engineering, Computer Science, and Informatics in Semarang, Indonesia. This conference provides academicians, researchers, professionals, and students from various engineering fields and with cross-disciplinary working or interested in the field of electrical engineering, computer science, and informatics to share and to present their works and findings to the world. I would I would like to express my highly gratitude to all participants for attending, sharing, and presenting your ideas and experience in this interesting conference. Almost 120 papers had been submitted to EECSI 2021. However, the only high-quality papers are selected and accepted to be presented in this event. We are also thankful to all international committee, international reviewers, and steering committee for their valuable support. I would like to give praise to all partners in publication and sponsorship for their valuable support. Organizing a prestigious conference was incredibly challenging and would have been impossible to have without outstanding committees. Such that I would like to extend my sincerely appreciation to all organizing committees and volunteers from Universitas Islam Sultan Agung Semarang as a host and all colleagues from Universitas Diponegoro, Universitas Ahmad Dahlan, Universitas Sriwijaya, Universitas Muhammadiyah Malang, Universitas Gadjah Mada, Universitas Budi Luhur, University Teknologi Malaysia, College State Malaysia, and EIS Indonesian section for providing me with much needed support, advices, and assistance on all aspects of the conference. A special thanks also for IEEE Indonesian section for their contribution as technical co-sponsorship of the conference. We do hope that this event will encourage the collaboration among us now and in the future. We wish you all find opportunity to get rewarding technical program, intellectual inspiration, renew friendship, and forge innovation, and that everyone enjoy this conference. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Dr. Ahmad Marwanto, thank you very much for your speech.
Ladies and gentlemen, now we would like to warmly invite the Honorary Vice Rector for Academic Affairs of Universitas Islam Sultan Agung Semarang, Associate Professor Dr. Umar Ma'ruf, to give welcoming speech and opening remarks. Ladies and gentlemen, please welcome Associate Professor Dr. Umar Ma'ruf.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Alhamdulillah wa ni'matillah wa la haula wa la quwata illa billah. Asyhadu an la ilaha illallah wahdahu la Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah wa syukurillah wa ni'matillah wa la haula wa la quwata illa billah. Asyhadu an la ilaha illallah wahdahu la syarikalah wa asyhadu anna Muhammadan abduhu wa rasuluh. Allahumma sholli wa sallim wa barik ala Muhammad wa ala ali sayyidina Muhammad. Praise and gratitude to Allah, God Almighty, who keeps granting us His grace, gifts, and guidance, as well as the implementation of the 8th International Conference on Electrical Engineering, Computer Science, and Informatics 2021, hosted by Universitas Islam Sultan Agung Unisula Semarang. The conference this year is interesting, Break Toward Industrial Revolution 4.0 and its application on electrical, electronics, computer science, and informatics for humanity. The event is intended to provide technical forum and research discussion related to advanced engineering on electrical and electronics, computer science, and informatics. Hereby, I would like to congratulate the Industrial Technology Faculty Unisula for the effort in organizing the 2021 EECSI International Conference on Electrical Engineering, Computer Science, and Informatics. My highest appreciation is also addressed to all organizations such as Universitas Diponegoro, Universitas Ahmad Dahlan, Universitas Sriwijaya, Universitas Muhammadiyah Malang, Universitas Budi Luhur, and University Teknologi Malaysia for their support in this mutual collaboration. Without the full and valuable support from the International Committee, international reviewers, and steering committee, this international conference remains a dedicated discourse without high commitment to conduct. My deepest gratitude is also devoted to IEEE Indonesia section and IAES Indonesia section for their support as the sponsors and technical co-sponsorship, respectively, be the initial and continual collaboration in the future. To all speakers, presenters, and participants, thank you for participating and welcome to this conference. The success of this conference owes so much on your participation and contribution in promoting to the knowledge, information, and robust creativity. To end with, this conference expectedly becomes an arena to build mutual this among the academicians, researchers, industrials, and society. Finally, the 2021 EECSI International Conference on Electrical Engineering, Computer Science, and Informatics, with the words of Bismillahirrahmanirrahim, I declare that it is opened. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Associate Professor Dr. Umar Ma'ruf, for your speech and remarks.
Ladies and gentlemen, now it's time for taking picture. So we would like ask you to please kindly have your camera on Zoom, please. For the committee, okay, we will take wait. The second slide, so please wait until the camera on. Okay, from multimedia, is it? Okay, 1, 2, 3, the first slide. Okay, we are still waiting for some participants to have the camera on. Okay. First, next slide, please. Yeah, another slide. Okay. Okay, thank you very much. Ladies and gentlemen, now we are going to have the keynote speech. We will start the keynote speaker at sharp at 9 o'clock. So during you are waiting for the preparation, please you have the montage of EECSI and FPI Unisula. Thank you.
Nowadays, Semarang is famous of becoming one of the most considered city for education. One of the pillars of higher education in Semarang is Unisula, Sultan Agung Islamic University. It is one among the universities located in the city. It was established by Sultan Agung Wakaf Foundation in May 20, 1962. Unisula offers a comprehensive Islamic-based educational concept through Islamic academic culture as its education strategy. This is believed to be an educational concept that meets the need for reasoned education, focusing more on knowledge transfer. During their study in the university, the students are educated to strengthen their Islamic spirit and science and technology through education for Aqidah, worship and moral, through congregational prayer, Islamic dressing, Toharo, exemplary, Islamic hospitality, life quality, strengthening Iqra spirit, developing science and technology based on Islamic values, Islamic learning society, and science and technology appreciation. By generating an excellent, faithful, competitive, and competent generation, this educational breakthrough is expected to be something that can meet the recent challenge. Unisula has various excellent facilities, including having a modern library accredited A, which plays an essential role in the process of building the pillar of Islamic learning society development. As academic main support, the availability of laboratories are significantly needed. Unisula puts great effort to meet the needs and make it as priority to continuously develop. A very representative Islamic boarding house is available for students coming from other cities, especially those majoring in nursery, midwifery, and history of Islamic civilization. Umanisa Food Court serves the need for students upon food. The cuisines are varied where students can select. This is likewise facilitated with Student Entrepreneurial Center. University Mosque, or popularly recognized as the Mosque of Abu Bakar As-Sagaf. Teaching Hospital, which is integrated with Sultan Agung Islamic Hospital, has become one of the excellent facilities admitted of its excellence in service. To nourish passion and talent of students, Unisula providing various student activity units such as Mapala, Taekwondo, Tarung Derajat, Pencak Silat, Indonesian Red Cross, Islam Practicing Student Activity Units, Art and Culture Group, Menwa, Scout, and many others. Sultan Agung Islamic University has also been actively involved in the community service. One of the endeavor is made by doing collaborative work with the Ministry of Social Indonesian Republic in succeeding 100 Rumah Desa Sejahtera Mandiri program. This program is created to improve the life quality of people around the village through fixing the houses into more livable. As world-class university, Sultan Agung Islamic University has become a choice for students from other countries to pursue their education. Unisula is also proven to be successful in taking their students or graduates to continue their further education in overseas universities. In order to be skillful in international languages, Unisula has also faced international language program of selection such English, Arab, and Korean language. In April 2016, students of Unisula gained a remarkable world-class achievement on winning robotic competition held in Trinity College, USA as the general champion by defeating other contestants from China, Israel, US, and some other countries. Unisula is greatly supported by expert lecturers in the fields. Professor is Imam Wahyudi DEA, an expert in the field of water management, is one among many professors working in this university. During his employment, he has contributed to the establishment of the first Delta Center on climate change in Indonesia.
Unisula, Universitas Islam Sultan Agung, now have one center excellent named Delta Center on Climate Change that works on research on Delta area, including coastal area, estuary area, river area as well, and that occur some problem like sea level rise, land subsidence, and climate anomaly. And to support this research, we have some cooperation, especially with Rotterdam University in the Netherlands and University of France.
With all the competitive excellences, it is expected that the graduates will succeed to respond and win the tight competition in this recent global era.
Ladies and gentlemen, we are about to have the keynote speeches of EECSI 2021. Now we would like to warmly invite the first keynote speaker, Professor Dr. Sepia Mahdalila Idrus, Professor of Electrical Engineering, University Technology Malaysia. This session will be chaired by Dr. Suryani Alifah, lecturer from Electrical Engineering Department, Universitas Islam Sultan Agung Semarang. I will pass the mic to Dr. Suryani Alifah. The time is yours.
Thank you, Master of Ceremony. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning,
Waalaikumsalam
everyone.
warahmatullahi wabarakatuh.
Ladies and gentlemen, now we are come to the first keynote speech session. Our keynote speaker today is very special person, the Honorable Professor Dr. Sefia Mahdaliza Idrus. Assalamualaikum, Prof. Sefia. Assalamualaikum, Prof.
Waalaikumsalam, Dr. Suryani.
Nice to meet you again. Okay, let me introduce Prof. Sefia. She received her bachelor in electrical engineering and master in engineering management, both in University Technology Malaysia, and her PhD in optical communication in 2004 from University of Warwick, United Kingdom. Her main research interests are optical communication system and network, optoelectronic design, and engineering management. Her research output have been translated into a number of publications with H index of Scopus is 15 and IPR, including a high-can reference to optical wireless communication, IR connectivity, published by Taylor and Francis, 49 book chapter and monographs, over 200 research paper, 8 patent granted and 36 patent filing, and hold 31 UTM copyright. She is actively involved in a number of industrial and international research collaboration projects. To date, she has been involved in 84 research and consultation projects with a total value of 25 million US dollar. Currently, she is the Deputy Dean in Development and Alumni of Faculty of Engineering, University Technology Malaysia. She is also the founder and director of UTM spin-off company, Aismat Urus SDN Birhat, successfully commercialized her invention, a novel airtime-based mobile micropayment solution and application-centric IoT-based mobile enforcement device for smart city. Based on her active contribution with industry of smart city solution, she has been awarded 51 Most Impactful Smart City Leaders 2019 Award in conjunction with World CSR Day and World Sustainability Congress 2019 in Mumbai, India on March 2019. And the important one, she led a 4 years G2G project on radar over fiber foreign object debris detection system fit trial at Kuala Lumpur International Airport KLIA, a collaboration project between UTM, Hitachi Kokusai Electric Japan, and Malaysia Airport Sepang under financial support from Ministry of International Affairs and Communication Japan. The project has made KLIA and Malaysia as one focal point for development of high precision millimeter wave radar at 90 to 100 gigs range. Ladies and gentlemen, in this occasion, Professor Dr. Sefia Mahdaliza Idrus will be shared with us the successful collaborative Malaysia and Japan research project on foreign object debris detection system, experiment and field trial at KLIA Airport. This FODDS system is very important since foreign object debris on airport runway can cause serious problem at planes and airport operator if not removed immediately, such as an accident and runway closure. Millimeter wave radar is often chosen as the sensor of the automated FOD detection system due to its high sensitivity, high range, resolution, and weather robustness. And now, please welcome Professor Dr. Sefia Mahdaliza Idrus. We have 60 minutes to hear her presentation, see her video, and for the question and answer session. Time is yours, Professor Sefia.
Assalamualaikum. Bismillahirrahmanirrahim. Alhamdulillah. Thank you very much, Madam Chair, Session Chair, Dr. Suryani Alifah, my BFF, best friend forever. Thank you, Doctor. Honorable Conference Chair, congratulations, Dr. Arif Marwanto. It's a very big conference. I think the numbers of participation is very high. Congrats to all the committee. Of course, to our honorable guest, Associate Professor Dr. Omar Ma'ruf. And respected keynotes, invited speakers, dear EECSI participants and also contributors. I shall begin my talk. Thank you, EECSI 2021 for inviting me. Everyone can hear my voice clearly? Please check, organizer.
Yes.
Okay, now I'm sharing my presentation. Thank you, Dr. Suryani, for long acknowledging my works. But today I would like to focus on our current project about the radar over fiber. And thank you for inviting me as a keynote speech of the 8th International Conference on Electrical Engineering, Computer Science and Information. Everyone here, I can see here there are 77 participants this morning. This is UTM. This is our campus. Can you see the green view of UTM? Hopefully, Dr. Suryani, Dr. Arif Marwanto, Miss UTM. You can see at the middle of UTM is the mosque. Okay, this is UTM mosque. Can you see? All right. And surrounded by the campus, then surrounded by the colleges, is same as Unisula. The setup of UTM is based on the Islamic value. The architecture is based on the Madinah. You know, Madinah is Islamic second key cities after Mecca. So this is the thing. The middle of the campus is the mosque, the main mosque of UTM. I'm Sylvia. I just would like to share some of my interests. Hopefully, the participants, all the docents who come in here can continue. Maybe we can collaborate in future. This is my research interest. Anything related to photonics and communication engineering, optical wireless communication, fiber optic communication system and network. My PhD and my main research is radio over fiber, which is a wired and wireless converged radio access network for massive IoT traffic. That's my direction. I'm also working on this optical wireless communication. This book published by CRC Press, together with my colleague, Dr. Ramirez Iniguez from the Glasgow Caledonian, and also Dr. Ziransan from Cambridge. And I'm actually working with our collaborators from Japan, which is WDM, millimeter wave radio over fiber wireless for high-speed rail communication. For today's speak, I didn't talk about this. I'm talking about the airport. This is the thing. We are working on the communication, but we serve transportation industry. For this one is for the train, high-speed rail communication. But the key topic that I will share today is about airport operation. Hopefully kita boleh bergabung, bekerjasama bapa-bapa, ibu-ibu dalam bidang ini bersama. My research interest is related, and you know, the long haul for the optical, metropolitan, for the home access and board inter and so on, it's expanding and scaling. And of course, the photonic diffusing into other application sector, health, biophotonics, environment sensing, and security imaging. Yeah? And now, yeah, not only that, yeah, radio or fiber, optical communication also supporting runway civilian. You can see me here, ibu yang baju merah inilah saya. Saya di airport dalam 4 tahun ini, working with my colleagues, yeah, a quite huge number of researcher working on this project, and 2 of them are also contributing in this conference. Dr. Sumiati and also Miss Akilah will share with you some of the works on this as well. Okay, this is the topic. I was asked by Dr. Arif, Prosivia, please talk about this. Okay, I said, all right, I can give some, but not so detailed on the fundamental. I would like to share with you the experience, how to conduct the project, how is it the scale of this project, and hopefully it can inspire especially researcher out there, to venture to this kind of project. One thing that I really sure is, if you really focus on your expertise, on your work, start from your PhD until now, definitely one day you will go to the much higher level, which is the application of your research. This is the thing. I'm working on the radio fiber since my PhD back 20 years ago. 2 decades working on radio fiber. But now, I'm realizing on the operation. Allow me to share with you for the next 55 minutes. Our works from research to airport operation. This is the project, high precision foreign object debris detection system at the Kuala Lumpur International Airport. Okay, this is the runway 2, 32 left, 14 right, at the KLIA. That this is our lab, this is our field work, to test our system, to see how it works. The research still ongoing, still actively, quite tired actually, but we really enjoy the journey. All right, supported by the Ministry of Internal Affairs of Communication Japan, the funder, supported by Japan Civil Aviation Bureau. I think in Indonesia also have it. You have a Civil Aviation Bureau as well. This one is by Japan Civil Aviation Bureau. And by our ministry, Kementerian Komunikasi and Multimedia Malaysia, Civil Aviation Authority of Malaysia, and definitely supported by the MCMC, Multimedia Communication, and MCMC is the regulator. Of course, when we work in the radio spectrum, all regulated by this agency. I think you have similar, right, in Indonesia? There is agency will monitor to see any new spectrum that you venture is safe to the public and according to the international standard. But the thing is, 90 to 100 gigahertz is considered new, is millimeter wave region, and some we can say 100 gigs is considered terahertz region, and currently being regulated. What we work now is actually getting a data, come up with the practical data to contribute to international standard at ITUR. That's the one of the key objective of this project. All right. All right, let me share with you. It's a big project. It's involved many parties. Previously is by the agency and the ministry who support us. And in terms of industrial, the industry partners, Malaysia Airport Sepang, Sdn Bhd, which is the company who operate and operate the KLIA. KLIA is the largest Kuala Lumpur, the largest airport, the busiest airport in Malaysia. I think some of the travelers from Indonesia will transit in Kuala Lumpur before they embark to other journeys. Hopefully after the pandemic, please come to Malaysia, landed in KLIA. Okay, Dr. Suriani, Dr. Arif, please come back to Malaysia. Okay. The second industry partner is Hitachi Kokusai Electric. The product is Hitachi, And the company, my spin-off company, iSmart Urus Sdn Bhd, is supporting in terms of the project management consultant. All right, in terms of research, UTM, NICT Japan, Waseda University Japan, and also ENRI Japan. NICT is the research agency under MIC. ENRI is the research agency under MOT of Japan. All right, and this is the research partner. So we work together beginnings 2016, and we start the real work in Malaysia 2017. Allow me to share with you. Hopefully it will inspire. It is something that my background is communication, and definitely I'm clearly dedicated in optical communication. But however, the idea, the application will be relates to other sector as well, and also based on the application. Okay, one thing as a background about this work is focusing on the transportation aviation industry. Transportation by airplane is a key infrastructure in modern society, and we have to keep these facilities safe, and also definitely many project, many research also working in this industry. All right, and our key issue, the key problem that we looking for to eliminate at the airport is FOD, foreign object debris. Foreign object debris is defined as any object located in an inappropriate location in the airport environment that has the capacity to injure airport or airline personnel and damage aircraft. I will share with you debris, kalau bahasa Indonesianya sama dalam Malaysia sampah, sampah gitu which is something unknown, something sorry, saya lupa nak off, maaf ya. Okay, and this is the thing that we would like to, we need to monitor to make sure this runway are clean, are clear from FOD. All right, and this is FOD. It's something like this. This one is considered titanium debris, and it's really dangerous. It's not just harm the aircraft. That's something that we really worried is the passenger. The passenger, and there is a big history in aviation industry. One big company vanished from the industry because of this single 2 centimeter of debris. All right. All right, you see here the tragedy of this aircraft, Concorde. Have you heard Concorde? I think my colleague, Dr. Surani, Dr. Arif, maybe we know. We know about this very big accident. Very sad. All the 100 passengers vanished on board and the flight, and also 4 people on the ground because of this debris, foreign object debris. It's happened, the aircraft, the Air France, you never seen this Concorde anymore. The company vanished, they closed down the operation. No longer Concorde, is becoming history. Because of what? Because of this titanium alloy, remember? Titanium alloy in the width of 2.5 centimeter, length 42 centimeter. It's very small. Make a huge accident. There is a lot of others record, but this is the most popular. And remember, there is a hadith, I think. Hopefully, my colleague in Unisula can help me. Remember, it's a sunnah. We need to remove anything in the pathway, right? Which is actually dangerous. This is the thing. In the runway, we need to remove it. We need to detect because it can cause a lot of huge disaster. This is the key issue that we're working on for this system. Okay, FOD item varying from this one. Sorry for the table. Table taken from FAA report 2015. You can see it's a small piece of concrete, standard nuts from service vehicle, yeah, mechanic branch, fuel cap, many things, yeah. Construction, yeah, runway infrastructure, yeah. For example, the asphalt debris, you know, the asphalt debris couldn't be, yeah, because, for example, yeah, there is an aircraft grounded a month because it's just a small chunk of asphalt, about 1 or 2 cm, entering the engine. So the maintenance, you know, to recover the aircraft is a huge cost to the airlines provider. Okay, so the safe and efficient operation of busy airport is important. Yeah, and I'm sharing you here is the statistic of runway closure due to the FOD, bird strike, debris or leakage, emergency landing, and so on. Yeah. So the debris is contributing the highest number, big numbers. Yeah. And regular manual inspection is conducted 4 times a day. Yeah. Is required by ICAO. ICAO is International Civil Aviation Organization, which is the organization under United Nations to regulate the industry. Okay, same as we at the communication sector, ITUR, that's the agency under United Nations. Additionally, temporal runway closure by accident occur many times. This closure raise inefficient operation of runway. Improvement of FOD inspection after accident is one of the key issues. Just remember, there is a lot of the minor accidents, small accidents at the runway. For example, the tire burst. So checking to make sure the runway is safe to be landed, to be used by next aircraft is really important. So it will involve cost there. All right, I'm sharing you here one of the from our literature. The social cost delay caused by the FOD or bird strike, roughly estimate. One of the popular FOD recently in this month. Oh, okay, sorry. Last month on September, there is a delay about 1 hour at the Narita International Airport. Turtle, a small turtle, they found it in the runway. So something like this. So whatever it is, this is the record for 2015. You can see for the Soekarno-Hatta International Airport, Indonesia. You can see the estimate cost, the estimate total cost in terms of USD is about almost 4 million USD. And for the KLIA, something like that, 3 million something USD. It's really huge. All right. As engineer, we work to improve the system because now, most of the airport, is they're monitoring the runway checking, which is I just mentioned to you. By standard, need to be monitored to check the runway 4 times a day, every 6 hours manually. But you know the human factor. Some of the workers, some of the ground crew of the airport, they cannot see the debris. A very small debris, dangerous. So there is a neat system. In terms of this, it can be laser, ultrasonic, optical imaging, telescope, or hybrid radar or LiDAR. So a lot of these research working and contributing on improving detection and monitoring technique. So detection system for small metallic FOD. The system need to have ability to detect tiny objects, display the situation of the runway, can support 24 hours, 365 days operation. Remember, the airport operate 24 hours. And some of the busy airport, the transition between next to next aircraft just only 2 minutes, 3 minutes interval. And many decisions for construction and setup, because most of the airport nowadays are matured, active. You cannot simply to close the airport to install the system. We need to design the system that workable and economically viable to the airport. So imaging and sensing system with both high resolution and wide coverage cannot be realized by optical or laser technology only. All right, because we as at the photonic group, we thought imaging sensing system is enough. No, it's not like that. We need to have something that much more reliable to support the optical imaging. We can have optical imaging to monitor, but not fast enough actually. Then we need a radar. But we know the limitation of radar. Okay, you know, I will share with you some a bit about radar. Excuse me, really. Okay. All right. This is the thing. We need to make sure the runway are clean. Are clear. All right. Before the aircraft landing, and also sorry, I missed the word. Sorry. All right. So what is the radar? Radar is radio detection and ranging. Sorry guys, I'm sharing with you a very basic. Hopefully some of you can have some basic understanding. I know, but this is the thing. Just recall back. Radar is the detection system that uses radio wave to determine the range, angle, or velocity of the object. To detect aircraft, ship, spacecraft, guided missiles, motor vehicle, weather formation, and terrain. Remember this second line here. Some of us imagine radar only for big size of object. But now we need to study, we need to do some research, we need to work on what kind of radar can detect small object, which is less than 3 centimeter. This is something that very simple that we relate back to the electromagnetic wave. We know the relationship of the wavelength and the size of the object that can be detected by the radar. So the application is it can be in the air and also terrestrial traffic control, astronomy, and so on. But now we embark to another journey, which is bring in the radar to detect small size. Nowadays, at this century, at this 10 years, working on this small size, maybe in future we can use radar capability to detect much smaller object. All right. Okay. Right, and this is the marine radar antenna. This one airport civilian radar. All right, this is me. Can you spot? This is one of my work with the Petronas. Can you spot the marine radar above me? So all this radar actually using a much longer wavelength. They detect huge and big size of object. The one that we need to use at the runway, then they have capability to detect smaller object, very small object. All right. So in terms of the basic understanding, in terms of the RCS value, RCS is the radar cross-section, meaning that the translation of the size and the reflection power of the object detected, because radar concept is sending the radio wave and then echoing back to the radar itself, and that's the way it works. So you can see here for the big aircraft like AirAsia, this one, you can see the RCS about 25 dBSM. All right. For the small aircraft, about 15 dBSM. For the car, there is a lot of application for radar at the monitoring vehicle. Is about 10 dBSM. And human, somewhere like this, depending on your size. All right. My size bigger than Dr. Suryani. Right, Dr. Suryani, you are smaller than me, right? Thank God. Like me, my RCS value will be larger than Dr. Suryani. So This is the thing, the size. And then for the smaller metallic cylinder, 1 inch is something about negative 20 dBSM. All right, for the bird, is something about 35 dBSM. Remember, as I said just now, bird is really dangerous at the airport. A lot of accident occurs due to the bird. And you can start studying how to detect the bird, how to eliminate the bird at the airport. There is a huge of the opportunity to study on that. The one that we study is just like a very fixed FOD. We don't have capability to study moving bird far from the runway yet. All right. All right. This is the thing about the RCS value. And for the radar, the wavelength, the frequency are related to the RCS value. The shorter the wavelength, the smaller RCS object can be detected. All right, this is the hazardous object for the runway operation, which is require 90 to 100 gigahertz radar, which is fall under millimeter wave range. What is the millimeter wave range? Millimeter wave is 30 gigahertz to 300 gigahertz. And I think Dr. Suryani and also Dr. Arif also working on the millimeter wave region right now, right? And for the communication, we embark from this the frequency to millimeter wave, and the reason is because of the capacity. But now we use that range for the radar, all right? This is a conventional system available commercially, and some of it still under testing. For example, here, Kinetic UK TASIA, 94 gigahertz radar at the Heathrow Airport. Stratouch system, this is not radar but optical camera at Singapore, and also this EECSI system, Israel, FOD Tech at the Seattle Tacoma. But this system has some issue in terms of scan speed, cost, and so on. All right, this is the way as a researcher we need to work to understand the limitation of the existing technology and to use our knowledge to improve the design to come up with a new solution. Okay, that's the key to become continuously contributing researcher. All right, you need to keep reading. We need to keep studying what benefit from our knowledge, basic knowledge. All right, this is the thing, comparison FOD detection system, the organization, the FOD tag, and also TASIA, and the proposed system. It's not proposed anymore. It's start from this year. It already works at the KLIA, working together with the Hitachi, NICT, UTM, and also Waseda University, and also ENRI. We are working at the 92 to 100 gigahertz, maximum range about 500 meter, range resolution, which is proven 3 cm and lower. System throughput, we need to make sure system throughput is really fast. And second is a trial at the Narita International Airport and also Kuala Lumpur International Airport. All right, allow me to share with you the basic understanding about the system. All right. I believe most of you here have a Belbus background. Of course, for this project, we need Belbus background as well. We have a researcher in the radar system, researcher in the camera system, researcher at the imaging, image processing, network, IoT is combining. Okay, this is the thing. It's a big numbers of contributor. This is a radio over fiber connecting all these radar head through fiber, alerting the this is the control tower. If there is a FOD detect, alert to the waiting aircraft. That's the concept. And there is a control tower. Same as the communication, there is a central base station and also the antenna head at the end, at the remote area, same thing. So the concept is to detect, to confirm, to alert, to dispatch, and to remove and report. Okay, they just changed the concept of radio over fiber for communication. Now is for the radar system. The back end still the same, still need up conversion, still need higher frequency. All right, millimeter wave range. Okay, just some recall back about use cases of conventional radio fiber. Yeah, all right. Radio fiber used for sending radio frequency, optically modulated RF frequency through fiber, sending the information, the data to the remote mountain valley area, mobile base station antenna. I think, okay, allow me to recall, Dr. Suryani study is on the transceiver for radio fiber. And I think Dr. Arif working as well on radio fiber some times ago, hopefully will continue, all right? This optical fiber sending the RF to the tall building, and also subway system. This is radio fiber. Please read more about radio fiber. Everyone are welcome to join us in this research work, all right? And what is the RF system for this imaging, for this detection? You can see, same as the communication radio fiber, RF system consisting of many antenna units, RAU, linearly located along with the optical fiber to form linear shaped cell, waveform distribution to share RF signal. Okay, the object will be detected by the RF signal at the millimeter wave range, 90 to 100 gigahertz, along the runway, sending to the joints in the processing and also data center. This is the basic concept of radar over fiber. All right, so this 90 to 100 gigahertz at the runway. All right, the radar head is connected through fiber to the control system, and then also monitoring system to alert the aircraft so that aircraft didn't land. Of course, there is a protocol by this airport operator and can remove the FOD immediately. And that's why we need throughput. The throughput must be really, really fast. The centralized inner generator processor connected to millimeter wave remote radar heads by the radio over fiber network. All right, some of us at the radio over fiber, we working at the transceiver. Some of us working at the system, and then some of us are working at the conversion. And like me myself, for my PhD back 20 years ago, I'm working on the detector only. But when we continuing doing research, we go to much higher level from the device to the subsystem, system network, and so on. All right. Okay, of course, when we do research, we have colleagues to contribute in certain area to make it the system works. The idea are working. All right, the requirement on the millimeter wave radar system, millimeter wave radar system, there's something very basic in terms of fundamental. I didn't go to the equation and so on for this keynote speech. It's just like I know everyone have you can read more from our research if you interested. The basic understanding is the requirement, wavelength must be 10 times smaller wavelength is required for detection, in general. Bandwidth, broader bandwidth cause narrower range resolution. And 92 to 100 gigahertz is already assigned for radio location services in ITUR radio regulation. This is the thing, it's already regulated, but we as the working member for the standard working group, still working on how to standardize this radio allocation. All right, it's new to Malaysia. For your information, our works considered the highest emitted RF frequency in Malaysia when we start back in 2018. Okay, that's the record. So the wavelength must be approximately 3 millimeter, that able to detect 3 centimeter class of FOD. You can go to the basic equation, radar equation, then you can see the relationship of the wavelength. All right, the smaller the wavelength, the higher the frequency, the smaller of the object can be detected. And you need to know, The theoretical range resolution is 1.8 centimeter, meaning that you need huge bandwidth, which is 8 gigahertz. If you go for the 8 gigahertz, if you have a radar at 92, some of your lower sideband no longer at the allocated spectrum. So that's the trade-off that you need to play, how to design the system. All right. And then remember, the one of the challenge is the high atmospheric attenuation propagation loss limit the transmission distance less than 500 meter. And we require a number of radar heads to cover 4,000 meter class runway. International airport that can cover Boeing 380 large aircraft need 400 meter. For the Soekarno-Hatta, the runway is about 4.5 kilometer. For the KLIA, 4.5 kilometer. About 4,500 meter. So if 500, you can guess, we need about 7 to 8 radar head to cover the whole range of the runway. All right. Just another understanding about radar system. All right, this is the conventional, system. The conversion at the end of the radar head here. So each radar head is equipped with a high precision synthesizer, high energy consumption of DSP. This one is really high cost equipment and infra to locate the radar at this frequency range at the runway. All right, how to improve that? We introduce linear cell radar system, which is radio or fiber. You can see the different conversion of the millimeter wave happen at the control center, not at the RAU unit, at the remote area. All right. And high cost synthesizer DSP is centralized by antenna, remoting based on radio over fiber technology. Low cost equipment and also infra by centralization. Large scalability is suitable for airport runway FODD system. So this is the basics, understanding of radar or fiber. All right, back in 2017, the team, we start with the field trial at the Narita International Airport, runway B34R. The field trials still continue. Next airport for the work at the Sendai Airport. Right. Okay, this is the civilian area for radar units for the prototype. This is the prototype, a Singapore, and this is the radar, and supported by the camera, which is hybrid. All right, and the control unit, central unit at the NIA building. All right, this is the system, connected, radio over fiber to here at the antenna, as the diagram I shown earlier. All right. And along that, we embarked the journey FODDS Japan Malaysia Joint Field Trial. Kuala Lumpur International Airport is selected. I'm part of the team previously. Now I'm lead the project for this Japan Malaysia Joint Field Trial. Start from 2017 and still ongoing. All right, and this is something, we as a researcher, we also need to have a capability, dedication, engineering management, project management, how to manage this big scale of project, because you're not only, no longer doing the design, you're no longer doing the simulation, you're no longer doing the, that one, you go to the field, you need to construct the system at the real field, radar configuration, infrastructure, the first prototype, do the experiment, first experiment, the methodology must be really clear, start from the beginning, what experiment that you need to conduct, and before you start the field trial, so that you can manage the project well, and you can, because you need to remember the field work is airport. It's not easy to enter airport and the runway is active, all right? so on. All this journey for the team. Thank you very much for the contribution of the team members for these works. Start from the experiment 1, 2, 3 until now. Now we are at the field trial phase 2. Okay, of course, as a researcher, we also need to do work at this legal thing. You have to make sure all the documents are in place. MOC signing between all the organization. This is the president, Mr. Sakuma, president of Hitachi Kokusai, signing with this number 1 of National Airport Sepang, senior general manager, and also my big boss, vice chancellor. These memorandum are really important because we need to use all these documents in terms of technology transfer, getting the license, and so on. And there is an NDA to be signed, and so on. So this is the thing, And of course, we get a good coverage about our early works at the KLIA. All right. In terms of experiment, part of the methodology, FODDS experiment 1, and then go to the KLIA system fundamental design. Fundamental design is not the radio over fiber, but the fundamental design of the infrastructure. Okay, here you need to apply your basic knowledge of radio over fiber. Okay, how to lay the fiber, how to design and to utilize the budget. To make sure the budget enough for you to construct the infrastructure. Pole structure, E&E, fiber network installation, system installation, configuration, and then to conduct experiment, second experiment, third experiment. This has happened for almost 2 years. 2 years of work. 2 years of work. And a lot of traffic from Japan to Malaysia, researcher from Waseda and ICT coming down to Malaysia. The first experiment, okay, we already published the outcome of this experiment and also contributed to ITUR standard. First experiment in the February, UTM campus KLIA, to see the system capability during rain. And the challenge is to wait for rain to fall. It's not easy. We don't know when is the rain will coming down, right? But we need to gather the data. But you have to know, in every day of your works, there is a cost. And you are dealing with the radiation at 90 gigahertz. It's not safe sometimes if you are stay close to the system longer than allowable. All right, because of the radiation issue. We start with the UTM KL campus and the courtyard of MJIT. All right. All right, here is our field work at the UTM campus. UTM has 2 campuses. Our main campus is in Johor Bahru. This is our second campus, actually our first campus at the Kuala Lumpur. All right. All right, and for the first time, MCMC give a license at the frequency of 96 gigahertz, the highest frequency radiated in Malaysia. I can say radiated in Southeast Asia. And there is none other country at that time having this level of work at this millimeter wave. As I can see now, they only work at the 45 gigahertz for my work with the Telecom Malaysia at the Cyberjaya. All right. This is the thing, the antenna is set at the 3-cylinder, set to 50 meter far from the RAU. All right. They're very simple for the FOD during this first experiment to emulate the possible FOD at the runway. All right. The range resolution we measured. And then lucky us, there is a 1 day rainfall about 20 millimeter situation. And this is our key researcher, Dr. Kano from NICT, putting the FOD simulator. And you can see the value. Sorry for this one. We get the scatter, there's a scatter for the rain puddle, and we through this result we improve the system. All right, and this is the 2D imaging of the system. You can see clearly this is the radar. This is KL campus, UTM KL campus. The radar is 360 degree, moving. And for the 2D imaging, the rugby goal very clear, and also noise. And we need to remove the noise, and the noise level, and also the fans, and during the testing. And then after that, we move the system, the RU radar fiber for the propagation study at the KLIA CCT apron. So the methodology is you need to start the work at this somewhere that comfortable for us to do the measurement before we go to the actual location. But apron is not runway, but it's good enough for us to test the capability of the system, in terms of performance. We use the old airport, KLIA LCCT apron. Before this, KLIA have a low-cost carrier terminal which is already closed, and KLIA allow us to do the experiment here. All right, this one, the location, and we put the radar there, and doing this experiment using all those FOD and also FOD simulator. Okay, just for us to understand, this is moving Dr. Rashidi and Dr. Farabi. You can see clearly their signal moving, leaving the radar. Can you see? Right? Dr. Syari, you can see that the signal came from the Dr. Farabi and Dr. Rashidi. And then also there is a car. And then now, Dr. Kano, you can see the Dr. Kano big signal.
Yeah, we see.
Big signal of Dr. Kano walking towards Dr. Rashidi and Dr. Farabi. This is the way we explain to the operator, to the airport, how is it the radar works, how is it they detect. All right, it's safe actually. All right, and after completing the experiment, we have the good data, we go for the fundamental design and start doing the very big job, which is survey, drawing, FODDS. This one took us about a year of work to do the land survey, cross-section survey. We need to make sure the radar are installed, the infra are ready for the radar installation. All right, this is the one, the location are chosen, runway 2 of KLIA, 14 right, 32L. And get approval from the Civil Aviation Malaysia. All right, approved by Civil Aviation, definitely, before we do the installation of the infrastructure. This is the overall picture of the radar, FODDS at the KLIA. There's a 12 radar head. Later, Dr. Surani will play you the video, to see the overall picture of the system. Okay, the 12 radar, FOD radar poles consist of RU and high definition camera along the runway, and then connected to the control center and next to the monitoring center at Airport Management Center. This is our design back in 2018. And we start constructing at 2018, end of 2018, and have completed in April 2019. All right. Okay. For the first field trial, the second experiment, we go for this only focusing on this area, only single radar. We need to study the situation before installing other radar. All right, and this is some of the photos, KLIA FOD construction. It's really tough, but we as researcher, Dr. Azura, Dr. Nadia, we involve, we have to be hands-on as well. We need to monitor, to work on this, to make sure the contractor are doing well. And FOD construction, installation, you can see the installation of the radar for the Singapore, not Singapore, three-legged pole at the RU13 during that time. Okay, installation for the experiment. Something contributed by our team, improving the Singapore NIA because radar using the Singapore is have an issue in terms of vibration. All right. We proposed a three-legged pole at the KLIA to support the RAU, lightning rod, and also rotating camera. And this is at the Narita International Airport. This is the one that we construct at the KLIA. Okay, this is the manager of the Malaysia Airport, Mr. Ramzi at the KLIA, came to the Narita to visit the site. And this Mr. Kashima, the head of this project from Hitachi at the KLIA. All right, yeah? So less lateral wind load, reduce vertical and also lateral vibration. And this one, yeah, the platform is runway level because most of the runway, they have a gradient, yeah, due to the civil requirement, no water puddle and so on, right? Radar spectrum license, we got the license, another history for us in Malaysia, all right? MCMC give us the license, and the license goes to under UTM, yeah, because it's under research, yeah, at the 96 gigahertz. Yeah, the first license, issued by MCMC at this range in Malaysia. The control center and also sorry, I don't know how to go back. It's okay. So for this experiment, we need to conduct the experiment line of sight experiment, yeah, vibration testing, FOD sample testing, and also system evaluation. Most of our work are conducted at night, during runway closure. In KLIA, because it's a busy airport, they only close 4 hours every week. And we need to use that period to conduct our work, experiment, and so on. All right. Sorry, I have another 10 minutes. I try to make it fast. And then we completed the works, and there is a launching ceremony, mark the successful of Malaysia-Japan collaboration, 29 April 2019. You see, it's a lot of work need to be done, almost a year for the infra itself. All right. And this is some of the outcome, yeah, during that period. And the radar can detect very small FOD. Okay, this is my business card. It can detect 1 cm of FOD during experiment, the field trial. Right. This is the PPI image of the radar, and then this is the camera image of this high definition camera. One of the key outcome, yeah, the system FODDS not only detect the FOD, also can monitor the condition of the runway. We detect the crack, we report to the Malaysia Airport, detect the dent, yeah, which is also not safe to the aircraft, and small bird moving. Yeah, all right. Okay, I'm sharing here the real situation of FODDS trial. How is it detected by the radar? Radar detect, confirmed by camera. All right. You can see. Okay, you see can the airport crew, yeah, Oscar, yeah, they collect the FOD. All right. All right. And then the camera confirm, yeah, the runway is clear. The FOD is white cloth from the aircraft. You see, sometimes people throwing something. I don't know how is it, but even the white cloth is very soft. It's dangerous to the engine of the aircraft. All right, yeah? And the system is also supported by our IoT unit that developed by our team, which is EECSI Safety RC, yeah. All right, developed by our team. Yeah. All right, next experiment 3, to study the interference caused by reflection from the airplane. I think I just show you one of these experiment conducted by our team, my postdoc, Dr. Wan Hasbiza, and also our PhD student and the colleague here. And you can read the outcome from this one of the paper published based on this experiment. It's a huge work for this kind of experiment. We use the actual aircraft, Malaysia Airlines supporting us during this one. Next, FODDS field trial. And of course, during this, okay, this is the one, is already constructed. The photo taken, you can see all the radar head, 6 radar head, all right. Even though the project delayed due to the COVID-19 pandemic, but we still working, and successfully completed for the installation of 6 actual radar. Okay, previous radar is 96 gigahertz. Based on the study improving optimization, the radar now is working at the 93.1 gigahertz. So this is the one that we work on. Radar performance improvement at 93.1 gigahertz for the KLIA. Our engineer, project engineer, Mr. Sola, at the training at the Hitachi during that time. And of course, with the works, with the support of MCMC, we need to monitor to get the license and do the testing. All right. These are the radar head, the RAU, pole 22, 23, 24, 25. 2 is represent number runway 2. But because of the first radar groups, only 6, we install at the pole number 2, 3, 4, 5, 6, and 7. Hopefully in future, pole number 1, 8 until 11 will be installed in future. This is the photo of the system at the KLIA. All right. Now we are at the stage of the FODDS KLIA evaluation. Using the following the minimum aviation system performance MASPS of a foreign object debris detection system. This one, this is the field work, the location of the study. Hold on. Okay, sorry guys. All right. It's not moving. Hold on. Bentar kejap. It's not moving. This the area. The yellow color is for the during rain condition, 200 meter. Red color is for the during the clear sky, 500 meter. Can you see my screen moving? All right. Sorry, I need to check again. Allow me to share, Bu Yani. Right. Can you see the screen?
Okay. Okay, we see, Bro.
All right.
Already see.
All right. Okay, this is the measurement using EuroKE MASPS. We conduct the experiment at the RU 22, 23, 24, 25, 26. All right, the detail about this will be this one, FODDS KLIA evaluation. It's very tedious works. Need to put all the FOD at this location, P1 until P9, at the runway at night time. And we are given good support by the airport. They close the runway for 8 hours for us to conduct the field trial. These are the FOD during our system evaluation. This is the thing, all right. And FOD sample at the KLIA evaluation, according to this one, we need to get the data for all these FOD. All right, as well as the wildcat, cat is measured at the negative 35 DDSM. For the cat, kita tangkap kucing letak kat runway, measure. Bukan senang Pak Arif, it's not easy Pak Arif, don't laugh. Okay, sorry guys. Alright, then also eyes, to detect the how is it the measurement for eyes, because eyes chunk at the runway is also dangerous. We collect the data. Alright, and this is the thing, FOD evaluation. This one is the aircraft cover, the engine, you can see, this is Mr. Daniel. They put the aircraft cover and then measured by the radar, detected by the camera, and is measured at 24 dBSM. All right, and all as well as that. The above the photos is by our camera, my own camera. The lower is by this HDC high definition camera from this radar pole. Okay, all this the value. These are some of the evaluation activities still going on. It's not complete yet. We still need to continue because we start working on the measuring the radar capability during the monsoon season. All right. You can see this is the photo by the handphone. This is photo by our team through the HDC at the night time, and also this one by the crew. Dr. Sumiati is here. The detail, of course, our crew, we have to make sure the FOD are clear during the experiment. All right, supported by our postgraduate student and also researcher. All right, during night time and daytime. And the detail about this experiment will be presented by Miss Akila. Please attend her session at 2:15 this afternoon. Later is also sharing the detail about this experiment by Dr. Sumiati Amran, the key researcher for this project. She will share with you the detail. I didn't cover that in my keynote lecture. All right, and now, Alhamdulillah, from the February 2021, the FODDS KLIA is demonstrated and operation well at the KLIA. We successfully demonstrate and presented to the Japan Embassy, JCAP, Japan Embassy, and so on during that time. Everything went well, even though we struggled during the COVID, because during the COVID, we cannot bring in Japanese team to Malaysia. It's very difficult. The paperwork is very tough. We as researcher, we need also have the capability and dedication to work on all those tedious paperwork, all right? And this is during the demonstration to the Japanese and also government agency to mark the system are working well. And allow me to share with you, this is joint publication of FODDS field trial project. Hopefully, all my colleagues here, all my friends here, we not only contributing for this journal or conference, we also need to contribute to this standard. All right, we contributing to the ITUR under Working Party WP 5B1, FOD 292 gigahertz. I'm part of this Working Party. Presented for the first time on May 2019, and then July 2022, and also 2021. This contribution by Malaysia together with Japan at the ITUR United Nations need to be, I think, few more meetings to be considered as a standard. Key contributor, of course, all these team from France and so on, that also working at this frequency range. And this is the joint publication. Please look through. I really welcome anyone who interested to work on this. And we also contributed to the IKO. IKO is the International Civil Aviation. They also have a standard committee there. And we keep contributing, and as well as ASTAP for Asia Pacific Telecommunication Standardization Forum for the radio over fiber. Okay, this is the impact and benefit. Yeah, I really hope all these my colleagues here, my friends, everyone, is a is a it can be referred as a successful Japan-Malaysia collaboration. High-end Japan technology transfer to Malaysia in terms of equipment. First radar in Malaysia at the 90 frequency range. Enhanced innovativeness and technology. Hopefully, the system can be adopted by Soekarno-Hatta Airport and other airport in Indonesia as well and around the region. And Quadruple Helix International Academy. And of course, my dedication and acknowledgement goes to this organization. Let me share with you, MIC, KKMM, Hitachi Kokusai, UTM, Malaysia Airport, CIM, JCAP, MCMC, Japan Embassy, Waseda University, NICT, ENRI, and also ISMA URUS. All right. This photo taken by the Berita Harian Malaysia. You can see here, this one. This is Malaysia Airlines. I get this photo from the media. The MH604 aircraft carried our first dose of COVID-19 vaccine, landed in KLIA at the 10 a.m. It's historical to Malaysia. I think same in Indonesia. The first vaccine coming to Malaysia. Do you see the FODDS? Can you spot FODDS radar tower in this photo?
Yep. Yes, Prof.
Yeah, this one, the first one.
You can see that, yeah.
And then the second one. The distance between the two towers is 500 meter. Remember our calculation, 500 meter. And if you land in the KLIA at the runway 2 from the international, you look at the right side, you can spot all these 9 radar at your left side. Left side or right side, you only can see 2 tower. All right. This is me with this equipment. The airport now is our laboratory, living laboratory. Okay, we're still working there for our research. And I would like to end my talk here. Terima kasih banyak-banyak. Thank you very much. Hopefully, I'm sharing good thing to you, everyone. I'm sorry for any drawback and so on. I would like to discuss more. You can contact me. You can email me if you're interested to collaborate with us. All right. Thank you very much. Ibu Suryani, Dr. Suryani, Dr. Arif Mawanto, and also everyone. I need to leave the room now because I need to send my daughter to airport. I'm sorry, but I will enter again a few minutes later through mobile, and please enjoy the video that will be played by Dr. Suryani. All right, thank you very much. I really welcome any question later. Thank you. All right, Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much. Thank you very much, Prof. Sevia, for giving such interesting and valuable presentation. And she has been shared the experience in successful experiment and field trial on FODDS up to implementation in KLIA Airport. Okay, the system overcome the issue on the previous system. It in scan speed, high cost, and small object size. The advantages of the system include the high speed scan in 10 seconds, small object size detection up to less than 3 centimeters. It's low operational cost, low emission of radio wave, and most importantly, a highly scalable system for BC Airport. And now, to improve our understanding about this presentation, we will play the video. Please enjoy the video. All right. The video already show, but maybe the sound not the sound still off, ya Pak Arif. Would you be play again the video, Pak Arif? We cannot hear the voice, Pak Arif. All right, ladies and gentlemen, sorry for not convenience.
Assalamualaikum Ibu Yani. Dr. Yani,
Ya,
saya dah
Waalaikumsalam. Ya, Waalaikumsalam, Prof. Suara nampak tak muncul.
Terima
Thank you
kasih.
terima kasih Prof. Sylvia. Selamat datang lagi Prof. Sylvia. Welcome Prof. Sylvia. Oke, thank
Ya.
you.
It's in a moving car.
Okay. Sorry for not inconvenience due to the sound of video is off. And now we come to the question and answer session. If you have any question, please raise hand or write in the chat. Please, I will deliver your question into the speaker. Okay, all right, Prof. Sylvia. We waiting for the question. I will small ask to Prof. Related to the low radiation, you can explain how this high frequency can give the low radiation.
Thank you, Dr. Suriani. Can you hear my voice? Because this one is
Yes. Yes, we hear, bro.
using my the line not so radiated by and safe. That's why we got the license. There is no issue for the maintenance team as well who working near to the radar. And of course, basic understanding about millimeter wave. The wavelength is very short, less than 3 cm. And of course, no issue at these biologically in our body, and definitely is safe for everyone who working on ground at the airport. All right. Hopefully, my answer is clearly received by everyone. Thank you, Doctor.
Okay, thank you, Prof. Okay, it is about since the wavelength is very small, so the radiation are very low. All right, Prof? Okay. Anyway, any question from participant? Please keep the question by raise hand or by write in the chat. We have time up to maybe.
Aku bangga lah kau boleh siap satu tempat.
Okay. Yeah. Any question from Pak Ika Nuryanto? Okay, Pak Ika Nuryanto have a question. How does radar detect small and non-metal object? What is the first detection, camera or radar first? Question from Pak Ika. Prof. Sylvia, please give the explanation.
Sorry, Dr. Tiani, again, what is the first FOD detected?
How does radar detect small and non-metal object? The ODDS can detect the metal object and non-metal object. Why? How to detect it? And in this FODDS system, they have a hybrid sensor. Firstly, radar, and the secondly is camera. And what is the first detection, camera or radar first? Which is the first detection?
All right. The sequence is first radar will detect the black body. I say the black body meaning that it can be organic, can be metal, can be a debris from this asphalt. And once the radar are detected, the camera also will focus focus on the FOD. The camera only leaving the location of the FOD once the FOD is already removed by the ground crew of the airport. All right. In simple way, radar will detect first, then camera will focus. The camera focus is to ensure the radar detect actual, the real FOD, to reduce the false alarm. Is it okay, Dr. Suryani?
Okay, one more, Prof. If object is not non-metal, how radar can detect non-metal object? Like the white cloth?
Yes, radar can detect. You know the concept of radar, the echo signal of the radiation. Radar can detect the water or any particle actually, regardless metal or organic or it's just that the RCS value for metal will be for the same size to organic. That's the thing. There's a fundamental equation on that, doctor. For very simple understanding in terms of radar, remember the meteorology radar. The radar detect the cloud, the water particle in the air. The same concept. For radar detecting the water or the small particle at the runway. Okay, thank you.
Okay, thank you, Prof. So the radar can detect non-metal object. If we have if we know about the sensor to water flow meter, also using radar, yeah, radar. Okay, and the first detect the object is radar, because the FODDS radar have a high speed scan, yeah, bro, 10 seconds. So the first detect is radar, and then the camera will focus. Okay, thank you for answer, bro. And maybe any question? Oh, one more question, bro. From
Really welcome.
Oh yeah. How configuration the camera information? Maybe this is a question, or yeah. How configuration the camera information? This is the second question, bro.
The algorithm is the camera is rotating as well 360 degrees, same as the radar. The camera will focus at the FOD for the crew for the Oscar, Oscar to check the FOD detect by the radar is sometimes something like this. The radar detect the bird. And then the radar will send the information to the system, and acknowledged by the camera. Camera will focus on the area, that area. Then the bird will moving or left the side. So the camera will inform again to the system. There's no FOD. So meaning that it's not FOD, it's a wildlife, yeah, it's moving, and the runway is safe. So the confirmation came by the camera, and one thing is the camera also give confirmation to the system. Once the FOD are removed by this Oscar, all right. That the basics algorithm of the system between the radar and also camera. The processing is happen at the control center, and of course, yeah, through our dashboard we can see reporting both from the radar as well as the camera. All right, doctor. in
Okay,
general.
thank you, Prof. Okay. Okay, any one question again? Due to the limited time, we have one question again. Please welcome for participant to give other question. Okay, all right, Prof. I think it is very clear.
Sorry, I cannot hear Dr. Suryani. The line not so
Okay,
good now.
sorry, maybe the network. Okay, thank you. I think there is no more question, but maybe your presentation is very clear.
All
And
right.
so, all right.
Just would like to say, please attend another two presentation by our members, Dr. Sumiati and also Miss Akila. Hopefully, you can have a better understanding in terms of the experiment in the afternoon. All right. Thank you.
Okay, thank you, Prof. The more information, more technical information, yeah, Prof. Okay, thank you. Thank you
Yes,
very
yes.
much, Professor Sylvia, from your valuable information. Hopefully, we can next can implement it the system in Indonesia. Okay. All right, ladies and gentlemen.
All right.
Amin. All right, ladies and gentlemen. Finally, we come to the end of part of our presentation. Our first keynote speakers. Our first keynote speech. We would like to say thanks again to Prof. Seria and to audience for active participation. Hopefully, the presentation will be beneficial for you all. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh. Thanks to yours, Master of Ceremony.
Waalaikumsalam. Thank you very much.
Thank you very much, Prof. Thank you very much.
Prof. Sylvia, please stay in Zoom for a while because we will have the token of appreciation. Thank you.
Thank you very much, Professor Dr. Sylvia Mahdelda Idrus, for sharing knowledge and expertise. And also thank you, Dr. Suryani Arifah, for guiding this session. Now we would like to present token of appreciation to Professor Dr. Sylvia Mahdelda Idrus for sharing your activities in this session.
Ladies and gentlemen, please give applause to our keynote speaker and our moderator for the first session. Thank you, Prof. Sylvia.
Thank you very much. Alhamdulillah.
Thank you, Prof. Thank you, Prof.
Thank you very much, Prof.
Assalamualaikum.
Waalaikumsalam.
Salam warahmatullahi wabarakatuh.
Ladies and gentlemen, now we would like to warmly invite the second keynote speaker today, Professor Dr. Jude Heman, Professor of Computational Intelligence from Karuna University, India. And this session will be chaired by Dr. Arif Marwanto, lecturer from Electrical Engineering Department, Universitas Islam, Sultan Agung, Semarang, Indonesia. So I will pass the mic to Dr. Arif Marwanto. The time is yours.
Thank you very much, Ibu Indah dan Mbak Reni. I will moderate it for Professor Dr. Jude Himens. Yeah, I will introduce his biography. Yeah, welcome to our conference, Prof. Good morning.
Good morning.
Okay. I will introduce about brief bibliography of Prof. Jude Hemans. Yeah, Professor Dr. Jude Hemans received his bachelor degree in electrical and computer engineering from Bharathiar University in 2002. Master of Engineering in Communication System from Anna University in 2006 and PhD from Karunia University in 2013. His research area includes computational intelligence and image processing. He has authored more than 170 research papers in reputable indexed international journal and Scopus. His cumulative impact factor is more than 270. He has published 37 edited books with reputable publishers such as Elsevier, Springer, and IET. And then he has been serving as associate indexed international journals such as IEEE Journal of Biomedical and Health Informatics, Soft Computing in IET Image Processing, Mathematical Problems in Engineering, and PhD Computer Science and Dines in Spain. Okay. Currently, he working as professor in Department of Electrical and Computer Engineering, Karunia University, Coimbatore, India. He also holds the position of visiting professor in Faculty of Electrical Engineering and Information Technology, University of Oradea, Ruman. Okay, please welcome Professor Dr. Jude Hemans to give his speech about automated feature extraction in deep learning models, a boon or a bane. Please welcome, Prof. Time is yours.
Thank you, Dr. Arif, and thank you all the organizers of this conference for inviting me to deliver my keynote speech today. Specifically, I should thank Professor Tol Sutkino, who is a long-term friend of mine, who has specifically invited me for this conference. And also I thank the other faculty members and the Master of Ceremony and all these people who are behind the role of this conference. Thank you very much. Hopefully, maybe one day we can meet face to face, either in Indonesia or in India.
Inshallah.
Let me share my screen. Professor Arif is somebody. That's fine. Yes, it is asking, should I admit them? Suryani Alifa.
Okay, you can continue, Prof.
Okay. Just a minute. Try to minimize this. Yeah. Is my screen visible?
Yeah. Okay, you can share screen. Okay. Okay.
Thank you once again. Thank you all participants who have joined this beautiful conference. And today I am going to give you some information about the deep learning concepts. I am sure you must have used deep learning for many of your applications, but there are some X factor or hidden dimensions in deep learning with which you can have a better understanding on your application or in your research output. Deep learning can be used in the communication field. It can be used for data analysis, in the informatics field, and so on. Let us see some specific feature of deep learning, and let us also check how it is going to be more superior than the machine learning techniques. So I am Dr. D. Jude Hemans, currently working as Associate Professor in Karunia University, and I also hold the additional position of Visiting Professor of Faculty of Electrical Engineering and Information Technology, University of Oradea, Romania. And this is some information about me. Professor Arif has given a detailed instruction or detailed information about me. But if you have joined late, you can just look at the screen and know about myself. But this screen is more than you. It is a tool which is used by me. As a researcher, it is not only gaining knowledge by traveling around for different conferences or workshops, but how much you put into practice is very, very important. Normally, people listen to the workshops, seminars, FDPs, conferences, and finally, if you are not putting into practice, things are not going to be beneficial for you. So as a researcher, you need to keep on checking yourself, maybe possibly every 1 month or 2 months. And you have to analyze how you perform in your research career. Say, for example, whenever I go for a seminar or a conference, I go back and check the slide. If there is any change in the bullet points or any additional points. If there is no change in the points, then it indicates that I was sitting idle for the past 1 month or 1.5 months, which is not good for a researcher. So you need to have a continuous improvement. Nobody can reach the topmost position in a single day. Rome was not built in a single day. But how do you proceed further? Slowly, every month, every week, every year, every 6 months. That is very, very important. So you can also have a self-evaluatory tool like this. Right? So whenever you check, you can find out whether how you move in your research area. So you must have an areas of interest. You have some specific route, right? Whenever we talk about electrical engineering, it's a vast area. So in that, what is your route? So your branches, your leaves can be anything allied with that, doesn't matter. Then you have the publications, and you must concentrate only on SCI-indexed publications or Web of Science publications, which will normally have an impact factor. In the least or in the worst possible case, you can go for a Scopus journal. Never ever go for any journals less than Scopus. It is not going to be useful to you in an international scenario. And you can have a cumulative impact factor, citations, H-index. I hope you must be knowing about that. Once publication is over, you have a projects, how many projects you have. Nowadays, international projects are also available. You can try on that. Another thing is how many books. There is a high possibility for publishing books too. Springer or Elsevier, the leading publishers, are looking for such book publications. So if possible, you can also proceed into that. Once you tick the first, second, and the third box, automatically you will be invited for many editorial positions of the journals. These are some of the journals in which I am holding the associate editor position. IEEE Transactions, Soft Computing, IET Image Processing, PRJ Computer Science, and many more. I have listed only few. So if you need any support in this type, you can always let me know. I am also an editorial board member or guest editor of many journals, and our famous Telkomnika is also there. I am also a member of IAES. Thank you very much for that. And you can also join the book series editor with Springer, Elsevier, and all the leading publishers. Right? Once you do all these things, you can have a part or a role in the research lab outside Indonesia. Right? Always focus on research works outside Indonesia. So there is a chance that you may get a different view on whatever you are doing. If you ask your friend or your colleague in your same university, maybe your thought may be same, but the people who are working outside maybe have different thoughts. So when you mix everything, you can give very good products. Right? These are some of the research labs in which I am associated with. That doesn't mean that we can sit idle. Every Tuesday, every Wednesday, every Thursday, we have a meet and we will have an assignment for our own. Right? We have a target, we have a deadline, and we try to finish all these things. Once that, you will be asked to deliver talks, and you will be known outside your country too. So this is the way how a researcher should proceed. So 50% gaining knowledge, and the next 50% is how you put it into practice. And for all these things, you need to have good research collaborations. If you think that I will do it on my own, it may not be possible. So try to have good collaboration with people outside your country so that you can grow in your research career. So the agenda, coming back to the agenda for our presentation, I will talk about a few information about why should we go for deep learning, or in other words, why the complete world is moving towards deep learning, the types of deep learning approaches, and we are going to see one deep learning approach which we call it as convolutional neural network in detail. Most probably, you would have used it with the help of Python and MATLAB. We have all the inbuilt commands available. But if you can understand the background information, then there is a good chance that you can develop some modified networks. That is the need of the hour. The research is not something like something is already existing, you take that and use it for your application. No. What innovation you bring, what thought you apply in that method, that is very, very important. For that, you need to have a complete understanding on what is happening in the background. So that is what I am going to give you. Maybe I can give you one application of how we can make use of CNN, and I will finally end up with open research problems and some question answer session. Now the time is 9:10. Probably I will take another 50 minutes. By 10, I will try to wind up my presentation, and another 10 minutes or 15 minutes, maybe we can have a question answer session. Sometimes maybe 5 or 10 minutes I may take extra, maybe kindly bear with me. The need for deep learning approaches. When you closely observe how deep learning evolved, why the complete world is running behind deep learning whenever artificial intelligence is the main focal point. The reason is we have a very good advantage in comparison to the earlier machine learning techniques. So what happens? You can see the complete evolution scenario right from 1940 till 2010. And in 2010, you can see Professor Hinton's photo. He's the professor, the father of deep learning, who is a professor in Canada, I guess. So these people are responsible for forming the different evolution, how a simple artificial neural network has given a way to a complete deep neural network or deep learning approach. Another point you have to keep in mind is in 1940, you have a method which has drawbacks. In 1950, they overcome those drawbacks, but again, there will be some other drawbacks. In all the 10-year decade, every 10 years or every decade, a new methodology has come up in the scenario of artificial neural networks or machine learning. But if you closely observe, each one of them has their own drawback. That's why system shifted from one method to another method, and now we are in the era of deep learning or deep neural network. Interestingly, deep learning also has its own drawbacks. So the idea which I'm going to try to say is, don't get afraid of forming some new neural networks or new methodologies. There will be mistakes, there will be problem, there will be error, but there will be some future person who will be taking care of your drawbacks and overcome your problem. So always try to develop something new. It may have its drawback, but one day it will be very much useful. So in 1940, we had the electronic brain and perceptron, then Adeline adaptive linear network. Then we had the XR problem where single layer neural networks are not that much efficient. Then we had a dark age, or we call it as AI winter, and no work was going on in the field of machine learning or artificial intelligence. Then in 1980s, the multi-layer artificial neural network came into existence, which we call it as backpropagation neural network. Then so many other neural networks joined together, which created a complete revolutionary in the field of machine learning, only till 2005. In mid-2005, deep learning came. It became the king, and it removed all the artificial neural networks for practical applications. Why? How? That is what we are going to see. So let us have a small comparison to understand this concept. What is artificial neural network and what is deep learning? Deep learning is the advanced representation of artificial neural network. I'm not very sure how many of you are already working in artificial neural networks or deep learning. If you are already working, you will understand that how deep learning evolved. But if you are new to deep learning, then definitely you must learn artificial neural networks first. That is the base. The word deep in deep learning corresponds to more layers. Deep learning, you have two words, deep and learning. The word deep in deep learning corresponds to more layers. Then you must know what is meant by a layer. A layer is nothing but a column-wise arrangement of neuron. Now I am showing you two diagrams, one on my right hand side and one on my left hand side. So on my left hand side, you can see a normal conventional artificial neural network, which I'm going to call it as non-deep neural network, which will have an input layer, which will have a hidden layer, and which will have an output layer. Right? So you can see that each layer is having some circles which corresponds to neurons, and there are some process going on within them. Now come to the diagram on my right hand side. You can see that no much difference between them. The only difference is the number of layers are increased. Right. Now you can ask me a question. These two diagrams look same, then can't we have artificial neural network with multiple layers? Already we have a multi-layer artificial neural network, which we call it as backpropagation neural network. If I just increase the layers in that, then it will act as a multi-layer neural network. Why should I name it as deep learning? Or why should I name it as deep neural network when there are no much difference apart from only the layers? A very good question. Then why do we need deep learning when already we have multi-layer artificial neural networks? Multi means you can have as many layers as you like. These three lines are very, very important to clear that doubt. More number of layers means high accuracy. So there is no doubt that you must go for more number of layers in an architecture. I will validate this statement when we go into the application part. But the conventional backpropagation neural network, when I increase the number of layers in that algorithm, it is not going to be beneficial for me in terms of performance measures. They fail or they give me very less accuracy. So what should I do? Architecture wise, it may look same, but I need to change the training algorithm. Training is also called as learning. So when you have more layers, if you follow the conventional training learning procedures, it will not work out. When you have more layers, you need to go for a different learning procedure. That procedure is called as learning or deep learning. That's why we say that whenever you use a normal or a conventional backpropagation neural network, it is not advisable to go for more than one hidden layers. If you go for more than one hidden layer, then there is a chance that your accuracy or your performance will drop down. So it is better if you want to go for, but you know that more number of layers means high accuracy. So definitely you need to go for some different training algorithm in comparison to our conventional artificial neural network. But the architecture will look the same except for the addition of the layers. But otherwise your algorithm and all the process are going to be different. Only that you can get a good performance. You can refer this web link where it is given that if you go for a conventional training algorithm with more number of layers, then you may not get a good result. Second point, why should we go for deep learning? It is based on the application point where deep learning methods does not need a feature extraction block in any pattern recognition applications. Pattern recognition is one of the commonly used application field of computer science, which is the focal point of this session too. Pattern identifying that this is a laptop, this is a mobile phone, this is a mask, this is a bag, this is a room, fan, tube light. This is called as pattern recognition. A human being can do that. How efficiently a machine can do that? Right? For that, let us take a simple case study of digit recognition or number recognition 0 to 9. So how will you use a machine to identify that this is 0 or this is 1 or this is 9? This is the block diagram for that. I hope most of you must have used this. This is a normal one, conventional one. You have a database input, you have a pre-processing, you have a feature extraction, you have a recognition. So recognition is the block where we make use of our conventional artificial neural network. Fine, very good. Now, when you go for deep learning based approach, now as per the first point, we came to know that it is always better to go for some architecture with more layers or deep learning. So when I go for deep learning, what is the change which I must make in the block diagram? Or is there no change? The answer is there is no feature extraction block in the deep learning process. This may increase your curiosity. If not feature extraction, how will I convert my image or signal into a number and give it to my network? When I say there is no feature extraction, there is no manual feature extraction. The feature extraction is being done automatically in the system. Most of the research scholars, students, they normally miss out on this point. They think that deep learning is also a conventional machine learning method, and as usual, they have a block diagram with feature extraction and they go on. But remember, friends, there is no manual feature extraction in deep learning. The algorithm itself is designed. That's why I told you in the first point, the algorithm is going to be different. It's designed in such a way that the feature extraction is done automatically. Now the question is, you can ask me, Professor, why should we go for manual feature extraction? Automated feature extraction. Why can't I go for manual feature extraction? All right, a good question again. Let us see. I can answer you by specifying the advantages of eliminating manual feature extraction. Or in other words, I can say it is the drawback of the manual feature extraction. What are those things? The necessity for expertise can be avoided. Take the case study of COVID-19. We design algorithms with the help of lung images, and we try to give it to the doctors so they can identify the COVID-19 pneumonia, SARS in a better way. But COVID-19 is a new disease. I am not an expert on that. But when I look at these images, they may look very close. They look similar. If I want to extract the characteristic features, how can I do that? Because I myself is not an expert. Right? Professor Arif is sitting on the other side, and I am sitting on here. Right? If somebody wants both of us to be differentiated, those person must have seen myself and Professor Arif. If he has seen only Professor Arif, maybe he will have some imagination about me, right? And then he may think it's a professor, he's an old guy and all those things, but that will be exactly wrong. And you will extract wrong features and give it to the machine. The machine will get confused and finally everything will go away. So manual feature extraction is not a good idea. But till 2005, whenever we were using artificial neural network, we are dependent only on manual feature extraction. If you would have done some papers on that, you will know that how difficult it is to find out the exact features for that application. Most of the time, we just refer the literature and try to find some features which may not be always correct. So if you can eliminate the manual feature extraction, then the accuracy or the performance measures will automatically increase, because the chance of a wrong feature entering the classification stage as per my previous block diagram is very less. So you make this as a single block. Feature extraction and recognition can be made as a single block, and the first step the algorithm will do is it will automatically extract the features and then give it to the recognition for the classification process. So this is the most crucial point a person working on deep learning must know, right? If you know this, then you can think about the innovative methods of how we can extract features in a deep learning model. So let me take a small case study to justify how manual feature extraction may not be good. Let us take the same digit recognition. You can think that we are going to extract some features on horizontal lines, vertical lines, and small circles. These are the three features. But assume that I am a layman to a digit recognition. So if I take vertical lines, one has a vertical line. So if I extract vertical line from this data set, one has a vertical line. If one alone has the vertical line, then it's okay. Absolutely fine. Your machine will correctly recognize that it is one. But interestingly, your digit 4 has a vertical line, and your 9 has a vertical line, your 7 can have a vertical line. Depends on how you write the digits. So there is a chance that more than one digit has the same vertical line. When you give this feature as input to the artificial neural network or the recognition system, it is going to get confused. You cannot blame the artificial neural network. There is no mistake with artificial neural network. The data which is given from the previous step is not correct. That's why I am eliminating that step itself, and I'm incorporating and giving the responsibility to the network or the algorithm itself. When you go for horizontal lines, you can write 0 in such a way you have an horizontal line, 4 will have an horizontal line, 3 can have an horizontal line, 7 can have an horizontal line, 5 have an horizontal line, so many. When you go for small circles, again 2, 6, 9, you can write 8 in such a way you have a small circle, 0, plenty of confusion, right? That's why you give the responsibility to the algorithm. It is going to take the good features and the performance is going to be enhanced. That's why deep learning is said to be much more efficient than other machine learning techniques. People blindly say that it is giving good accuracy. How it is giving good accuracy? You need to go in deep. Right? It is because of the increase in the number of layers and the removal of manual feature extraction. So these are some of the types. This is the complete machine learning techniques. Maybe it will be useful to you. And this is the deep learning part. And here we are going to talk about the convolutional neural network. So let us go into the convolutional neural network in detail. So need for CNN. Like how whenever you learn some new technologies or new topics, make sure that why should you study that? Why you should enter into research on that? Right? That background information should be known. Only if your base is very strong, you can automatically climb up in whatever technology you are learning. So similarly, you should learn, why should I go for learning CNN? Is the CNN the first framed deep learning model? The answer is no. Even before CNN, we have a method called as deep feed-forward neural network, but it has a drawback. Let us see what is the drawback. Take the same case study of number recognition. You can see two data, right? I have a machine. I have a deep feed-forward neural network in that machine, and it is programmed to recognize the digit 8 and digit 5. So whenever I give 8, it will tell it is 8. Whenever I give 5, it is going to tell it is 5. Absolutely fine, right? So I gave my test image 1 8, and it told me it is an 8. Then I gave my test image 2, it is told it is not an 8. Right? So it is programmed to recognize 8. Any digits if you give, it will recognize 8, and any other digits it will say it's not an 8. That's fine. Now look at the second set of data. Right? Look at the second set of data. I have given 8. The same machine 10 minutes back, it was able to correctly tell me that it is an 8. But now the same 8 is given, but it is saying that I do not have any idea. I am unable to recognize that. When I give 5, then again it is not able to recognize that it is whether it is an 8 or not. Then it is saying that what is this? What is the difference between the first set and the second set? What is the difference between the first set and second set? No much difference. 8 remains 8, 5 remains 5. But the only change is the position is changed. In the first set, 8 and 5 are in the center. In the second set, it is shifted to some other positions. So what happens here is, if the position of my region of interest is varied, deep feed-forward neural network will fail. That means our network is highly sensitive to the position of the digit. How many times can you expect your data or your region of interest to be in the middle? Hope every one of us will take selfies, right? Whenever you go for a tour, you take selfies everywhere. How many times do you take that selfie in such a way that your photo will be in the center? Not possible, right? If it is not possible, if a machine says that it is not so and so, how do you feel, right? That is not correct. So irrespective of my position, it must be able to correctly identify the region of interest. So how can we solve this? We have one option for this. You can write or you can train that specific machine with all possible positions of 8. How many positions of 8 is available? Infinite. How many size of 8 is available? Infinite. How can a human being can have so much data? Already deep learning is having so many layers, it is going to be computationally heavy. Now when you increase the number of images, it is going to be disastrous. So this option is not a good option. But if you are from computer science background, or if you are a computer scientist, you can argue that I have the NVIDIA graphic cards, GPUs I have with me. So time is not an issue, you may argue. But still my question is, if I am sitting, my name is Jude. If I am standing, how can my name change? It is going to remain the same. So this is the way how a human life is going on or evolving in this world. For every position change, if the name is changed, right, the world, the people cannot live in this world. It will be disastrous. So instead of going for this type of other add-ons, if I can find an algorithm which can detect or identify the patterns irrespective of the position, then that will be the best possible one. That's why people came into the concept of convolutional neural network. Right? But before going into convolutional neural network, we can see about the first letter C, which stands for convolution. When you say convolutional neural network or CNN, it is nothing but C plus NN, convolution plus neural network. So a normal neural network, first we are incorporating convolution. Why are we incorporating convolution? There are many advantages. That's what we are going to see now. So this is the mathematical definition for convolution. It is a mathematical operation on two functions which you must, if you are from electrical engineering, you must know, to produce a third function that is typically viewed as a modified version of one of the original functions. You take two data, F and G, you convolve with each other. When you convolve with each other, you will get a third data, say for example ABC, which is a modified version of one of the original functions, F or G. Now, one research scholar of Professor Hinton, he had this idea and he immediately took this convolution and he thought, I also need, if I'm having 8 in the center, if that algorithm itself can push it to different positions, then the chances of accuracy will be very high. I need not do that. Automatically, the system can do that. This thought struck his mind and immediately he took this convolution and he joined it with neural network. And the resultant is nowadays we have the concept of convolutional neural network. So the first duty of convolution is to have data in different positions, not manually, but it is automatically. So how can we do that? Let us take a simple image. You can look at this image. You can see a child sitting in the middle of the garden. That's fine. A human being can recognize that it is a child, but a machine, it will look for the position of the child. If he's in the center, it will tell, okay, it is a child. If he's not in the center, it will say it is not a child. So maybe a problem. So how can we solve this? How convolution solve this problem? You can look at this image now. You can see that the body part of the child is available in more than one frame, or the total image is divided into small sub images. Right? How many sub images you have? You have 77 small sub images. Convolution has the capability of dividing that. Now you can look at these images. You can look at the 6th slide, the 7th one, 8th one. you can see the body part of the child is available in more than one frame. In the previous case, when the image is treated as a whole, only one. But now you can see that the body portion of the child is available in more than one frames. So the chances of recognition that this is a child by that machine will be very high. And you can also see in the sixth, maybe the sixth one, you can see the head is in the rightmost corner. Seventh one, it is in the middle. The next one, it is in the leftmost corner. So it varies. The body portion of the child varies and the chances of recognition is very high. But remember, you are not going to do anything. You are not going to create infinite positions of data. The system itself is going to do. How it is going to do? It is going to do with the help of some of the image processing operators. Right? I am not very sure again how many of you are good in image processing, but if you are good in image processing, you must have heard about at least about the edge operators of Roberts, Prewitt's and Sobel operators. Right? So these are the operators which are used to split or divide an entire image into small pieces. So now once this convolution process is done, now you can mix it with the convolution neural network, our normal artificial neural network. That's why I told you, if you want to jump into deep learning, first you must have a complete idea on artificial neural network. So this is the complete structure, a simpler possible structure of CNN. You have an input image, you have a convolution process. This is what we have seen just now. We have some other process, max pooling. Then we have the fully connected neural network, and then it can recognize whether it is yes or no. Any application, right? Pattern recognition application, which is the focal point of our. There are some critical issues too that I will give you when we go for the final open research problems. So how to achieve step number one? So what is step number one? Your convolution is step number one. So let us see practically, more practically, how I can achieve step number one. Or when I say achieve step number one, it is all about how I can divide the entire image into small pieces. Right? So this is the image a human being will see. What we see is a dog, right? But what computers see is only numbers. Computers do not have emotion. They do not have any kindness, nothing. They can see only as numbers, the pixel values. Right? Now, I am going to play with these numbers and I am going to divide this image into small pieces. How am I going to do that? Let us assume an input of size 32 cross 32 cross 3. Right, a color image. So you have a third dimension 3, but 32 corresponds to the row, 32 corresponds to the column, and you can have the complete setup. Now I want to divide this into a small piece, or the machine wants to identify that it is a dog is there in the image. How can we do that? Assume you are the machine, right? Assume you are the machine and you are left in a dark room. Say for example a room as such where there is no tube light or no power, no current. It is completely dark. Now you are supposed to search something. Say for example you have left your mobile phone there. You want to search for your mobile phone. What will you do? You cannot see with your naked eye. So you will take the support of torchlight or a flashlight. Right? Now this torchlight, this flashlight is going to be useful for you to search. How will you search? You go out, take a torchlight or a flashlight, come back, and you will switch it on to some portion of the room. Remember, you have a large room and the torchlight is something which is useful to you. Now you switch on and you are checking whether a specific portion of the room is visible or not. It will be visible, and sometimes you can find the data and sometimes you will not be able to find the mobile phone. Now what will you do if you are not able to find out? You will move to the next position. Again, if it is not, you are not able to find out, what you will do? You will keep on moving throughout the room. You are actually scanning the complete room. Still, if you are not able to find, what will you do? You go out, you will take a better torch. Maybe the size of the torch, the visual area may be high, maybe its intensity may be high. You come back and again search for the. This is what a human being does. The same thing is going to be done by the machine also in our convolutional problem. So in the convolution problem, this big room in which I'm going to search for my mobile is equivalent to the image. This dog image, the complete image, where the machine is looking for some object, right? That is the original data, F. Now, I am taking the support of some duplicate data, right? The torchlight, right? That torchlight is called as the duplicate data, G. Do you remember the mathematical process of convolution? We need F and G. F is the original image, G is the duplicate data. When I convolve these two things together, I will be able to find the data. What is this torchlight? This torchlight, technically speaking, can be called as a edge operator. It is also a small matrix, maybe of size 5 cross 5, for example, right? So your original room is very big. That means your image is 32 cross 32, but your torchlight is very small. In the same way, your filter, we call it as a filter. The flashlight or the torchlight is called as a filter. It is also very small with a size of 5 cross 5. Now, when I convolve my 32 cross 32 original image with my 5 cross 5 torchlight or filter, right? What do you mean by convolution? Overlapping. Right? You take the torchlight and you overlap on a specific portion of the room. That's what we do. The same thing is being done by this convolution also. Right? Now you have a 5 cross 5 image. You have a 32 cross 32 image. You have a 5 cross 5 filter. Now you are going to convolve. Right? How do you do that? Each intensity value of a 5 cross 5. 5 cross 5 means 25. 32 cross 32 means maybe somewhere around 1064. Each pixel will be multiplied. Your 5 cross 5 will be taken, your filter will be taken, and it is placed on one specific portion of your image, exactly like how you switch on your torchlight on one specific portion of the room. Take this 5 cross 5 and place it on the 5 cross 5 position of that big image. Only one portion is visible, and in the same way, only some portion is overlapped with this 5 cross 5. So what happens with that process? Each data or each pixel value of 5 cross 5 will be multiplied with the 5 cross 5 region of your image, and they are summed up. The resultant will be a single number. Now what will you do? If you are not able to find out, you move the torch to the another position. Now you move the filter or the analogous to the torchlight to another position, another 5 cross 5 within the image, then another 5 cross 5, another 5 cross 5, and you are going to completely scan your data, and each time when you are scanning, you are going to get a single number. Say for example, if you are moving 9 locations, you will get 9 single numbers, and when you convert it into a 2-dimensional image, you will get a 3 cross 3 image. What is this 3 cross 3 image? This is the first small divided image of this complete image. We divided into 77 small tiles, right? So this is the first small image. If I want to get another small image, I need to go out, take another filter and come. So when I change my dimensions, when I change my size, the possibility the output will change and I can get another output. Likewise, depending upon your necessity, you can use as many filters you like, and you can get different small sub image. So this is the mathematical illustration of that. The pink color corresponds to the torchlight, or in our case, it is the filter, or we call it as a kernel, or we call it as a mask, or it is also an edge operator, a duplicate data, G. Now this blue color corresponds to the original image. So at a time, I am focusing on one specific, because it's a 3 cross 3 filter, another 3 cross 3 filter will be overlapped with that. So when I overlap, when I multiply them and add, I get a value of -4. Look at the extreme end, green color box, -4. So next time, what will I do? I change this 3 cross 3 filter to another position within the same image, not with the second image, within the same image. So likewise, I can repeat for 9 positions as per this example. That's why my first green color matrix is showing a 3 cross 3 matrix. Output 2, 6, 0, 5, 8, minus 4, 0, 1, minus 1. Now I take another filter. Another red color 3 cross 3 is another filter whose value is different. Dimension is different. The shape is different. It may be different. Now again I go for moving, overlapping, and again I get an output. Likewise, depending upon my slices, this is a 3-dimensional, that's why I have 3 slices. In the same image also you can do more number of filters, more number of small sub images. The original image in this example is 7 cross 7, but the output I have got is 3 cross 3. So this is the way how it will look like when you display your output, right? So this is the output. When you display it in the form of an image for a visual inspection, your output will look like this, right? So it is divided into 1, 2, 3, 4, 5, 6, 7, 9, 10. 10 sub images. I have got 10 sub images from my original image with the help of this process. Now, convolution has done the first process. What is the first process? Dividing my image into small pieces. So the chances of recognition is high. The second question is automated feature extraction. If I go for CNN, I will just give the car image. I will not do any feature extraction process. So how do we say that feature extraction is being done? Now you closely observe these 10 sub images. You can see that these are some front portion of your car. Some gray color pattern, small shades, dark shades, everything corresponds to the portion of the car. Indirectly, I am saying that each 28 cross 28 matrix or each output, whatever you got, is called as a feature descriptor. They are a feature. It is a feature. This small box is a feature. This is a feature. This is a feature. All 10 are features, right? But interestingly, can we identify the object with the help of those features? Can a machine identify with the help of the convolutional output features? I will give you a question, right? Assume I am talking about an animal, right? I am talking about an animal which is the original image. I have used this filter. This is the mask or kernel. I have done convolution process and I have got this output. Right? Now, based on this output, you must tell me what animal I am talking about. Can you guess? I can give just 1 minute to any one of the participants. You can unmute your mic and let me know what animal I am talking about. Quickly. I'll repeat once again. I have an animal in my mind, the original image. I have used this filter and I have done masking or I have done convolution on that. Now the resultant output is something like this. Now based on this, can you recognize what animal I am talking about? Quickly, somebody wants to make a guess?
It's a dog.
It's a dog. Thank you, Professor. Any other answer?
The elephant.
Elephant. Very good answer, right? So if I ask you, if I give more time, each one of you will give me different answers. But actually, I am talking about the back portion of the mouse. You are not able to recognize. That's what I want to validate. You are not able to recognize with the help of this small information. You are not able to recognize with the help of these features. Even though I say it is a feature, you are not able to do that. Why? It is not very clear. These are called as low-level features. When I'm switching on my torchlight on a specific portion, maybe I may look at a notice board. I may have a small edge or a line. Then I may think, okay, this may be my mobile. But when I come closer, it is not my mobile. It is something like notice board where some statements are written. So these are called as low-level features with which we cannot identify whether an object is so and so or not. Lines, curves, edges are called as low-level features. So how can I enhance the possibility of recognition? I need to have a higher level features. What do you mean by higher level features? Say, for example, if it is a cat, paws, eagles, claws, birds, beaks, so many things. But how can you get a higher level feature? You can get a higher level feature by having more convolution layers. Now, can you correlate it with the statement which I gave in the beginning of my presentation? More layers means more accuracy. So when you increase the number of convolution layers, it is doing feature extraction, but the first layer is doing low level feature extraction. The second layer is doing a better level feature extraction, and the higher level is doing the highest level feature extraction. So the machine can easily identify that this is so and so. That's why deep learning models are very, very complex. If you remove the number of layers, it will become an automatic normal artificial neural network, and it may not give you a good result. So you need to have more layers, you need to have automatic feature extraction, and also you need to have a different position variation of your original data. All these three things are done by this simple convolution process. Imagine if this idea would have struck me maybe 20 years back, I would have become world famous. Right? Simple idea. That is what the researchers must apply and think on. How can I develop new thing? How can I replace convolution with another mathematical operation so that the computational complexity will be reduced? It is up to the users to think about that. So when I have more number of layers, each time I can have a small line, then maybe a connecting line, a connecting line, a connecting line. I can get a square or a rectangle, a polygon, which may correspond to that specific object. So when I zoom on it, I can find the object. This is how human being does, and a machine is also going to do in the exact similar way. Remember, artificial neural networks or deep learning is based on our human brain. It's based on God's creation. God's creation can never fail, right? God's creation can never fail. So whatever methodology we are based on that, it is also going to give you high. So next one is your max pooling layer. I will try to go a bit fast. Next one is max pooling layer, the second layer. Now the question is, you have got many features, right? Now, if you remember the boy sitting on a duck in the garden, when we divided into many small sub-images, I told that you look at the 6th slide, where you can see the head in the rightmost position. But what about the first 5 sub-images? There is no body portion of the child found in that. That means each sub-image is a feature, but that feature may not have some useful information too. So what you can do, normally we will do some feature selection process, but instead of feature selection, which is a complex process which involves all optimization process, we can go for a simple max pooling layer where we can say that I'm going to remove the unwanted features which are extracted by the convolution layer. Unwanted sub-images which the convolution layer has generated with the help of the filter. So how can I find out? Whenever I have a convolution means just multiplication and addition. Whenever that output number is very high, then I can say useful information is there. Whenever the number is 0, no useful information. You can see there is a mismatch between the original image and the filter. So there you will get a value of 0. Right? So remove all the features or sub-images which is giving you a convolutional output of 0. Very simple. How can you do that? You can do with the help of a simple downsampling technique, which we call it as max pooling. Right? You arrange 4 features. Now you assume that this is one sub-image, this is another sub-image, this is another sub-image, this is another sub-image. Among these, you choose the sub-image which is having the highest value. Right? So you can take one. So nowadays the dimensions will be significantly reduced. But the question again is, how far I am accurate? If there are 2 sub features with the same value, which one should I choose? So far now it is being done randomly, but as a researcher you can think about something by which how can I improve this max pooling layer so that the process can still be efficient. So max pooling helps in reducing the dimension, and at the same time it avoids the unwanted features entering the system. If you observe deep learning is not from heaven. It is same thing as of our artificial neural network. But there are small changes here and there which is making them better than our artificial neural networks. And the third step is your fully connected layer, which is our normal artificial neural network, where your SGD algorithm is used for training, and you come back and change your filter parameters too. So if you want to have a good lecture on that, you can refer some of my videos, which is available as a free open source released by some of the institutions. And now I'm not going to touch on that. It is normal ANN which requires training as usual. So this is the architecture of CNN. How do we do the training? Same process, forward pass. First, you randomly initialize the weights, convolve with your original image, take the convolution output. Depending upon your necessity, you can have more layers. Then each time you will take the convolution output, you can pass it through the max pooling layer too. And then when you come to the fully connected layer, you will have your training process and you will have your error. CNN is also a supervised learning methodology. So you will have an error calculator in your fully connected layer output. Then come back, the reverse pass. You can come back and you can adjust your weights of the fully connected layer first. Then you come back and adjust the weights of the convolution layer. Adjusting the weights of the convolution layers is not that easy. It's not that easy as you think. It is not a single weight value as in our fully connected layer. It is a matrix. Matrix means inside that there are so many values. Right? So mathematically it is not that easy, but still if you can understand them, you can do it in the best possible way. So this process is repeated for a specified number of iterations till output is equal to target. Once trained, it can be tested with any unknown data. So this is the diagram which I want to give you. I am not very sure how many of you have understood that convolution is doing the process of feature extraction. I am not doing any feature extraction, but this red color dot where I have the convolution layer and max pooling layer, together they are responsible for the features. Once the features are selected or chosen, I am giving it to the normal artificial neural network for my classification. This is what's happening in our normal CNN. But because of the availability of Python, you need not do anything. You need not do the differentiation of mathematical process of the training. They have inbuilt commands. You choose some models and you will get the output. But behind that, what happens? That's why our research papers are not accepted. IEEE transactions, they expect the behind the scene process, that mathematical equations. So your paper will be accepted, and at the same time, you can also think in a different way. How can I replace something different so that a modified version of CNN can be generated? But one critical issue, as I told you earlier, is the number of layers. How many convolution layers should I go for? I told you, you go for many layers. If you ask me how many layers should I go for, even I do not have an answer. Right? It is still based on a trial and error method. Sometimes it will work, sometimes it will not work. It is also an area of research. So to avoid that, nowadays there are many pre-trained models available. Maybe you must be knowing about that: AlexNet, GoogleNet, ResNet, UNet, DeepNet, and VGGNet, VGG16, VGG19. So many combinations are available. It is available in Python. Just drop down, you will get the answer. But behind the screen, these are the concepts going on. Each of these pre-trained model will have their number of layers fixed, not like a random selection. So that's the difference. So softwares, I will suggest you to go for Python, but if you're already good in MATLAB, you can also make use of MATLAB. MATLAB 2019, I think now they have all the inbuilt options too. Requirements, a high-end processor is good, but it can be also done with a normal laptop. One of my research scholar, she has done with a normal laptop. So these are the different layers. Maybe, can I take another 5 minutes? 5 minutes time? 5 to 10 minutes?
5 minutes left.
Okay, sure.
Okay.
So these are the different layers which normally are available for BG16 and BGG19. So these layers corresponds to the number of convolution layers. More number of layers, more good features can be extracted. But the concept remains the same as we have seen earlier. I will just wind up with one small application, COVID-19. Recently, one of my research article, we have done a work on COVID-19, and it has been very well accepted by World Health Organization for practical implementation too. So if you want to do something with COVID-19, you can also do. You can go to this website, you can get plenty of images are available. When I downloaded 360 images, 295 and 16. Nowadays, I'm very sure with the increase in the number of cases, you can find plenty of images, right? So how will you identify COVID-19, pneumonia, SARS? If I'm not giving you the name below, you will not be able to identify which disease belongs to which name, right? All are confusing. So only for such applications, we should go for deep learning. Another common mistake a research scholar make is even a simple problem, she or he will try to make use of deep learning. Why? It is not necessary. Remember, only when your feature extraction fails, you need deep learning. Suppose if you want to recognize between a car and an aeroplane, sorry, a cat and an aeroplane. A cat is very smooth features. Aeroplane is completely different. So identifying them with an artificial neural network will not be a big task. It will be very easy. So in that case, you go with AI. Don't think that you need to make your research paper too big and complex to attract the editor. You go for deep learning. No, don't go for that. Choose a problem which is always complex and challenging, and then you can incorporate your deep learning. So this is a model we have chosen. And these are implementation parameters. Whenever you write a research paper on deep learning, definitely you must include all your implementation parameters. If you're using Python or MATLAB just to drop down, then it may be a problem, but try to get all these details from the background, because that will give good impression in the sights of the editors. And I don't have time to explain this Python code. Probably maybe some other time, maybe we can do that. So these are the performance measures, precision, recall, F1 score, accuracy. You must be knowing that the same thing which we use for ANN is used for deep learning also. So this is the results, right? This is one of the results where we can find between normal versus COVID-19 and pneumonia versus COVID-19, a two-level classification. I can easily find out whether this answer is correct or not. How can I do that? Normal versus COVID-19. Always they will be sufficiently different. Normal will not have white patches in the lungs. COVID-19 will have white patches. But when you go for pneumonia versus COVID-19, there is a complex, right? So that result of B will be always less. So don't think the editor can find out whether the answer is correct or not. They will easily find out. The expert can easily find out whether your answer is not correct or not. If you interchange the table, thinking that pneumonia versus COVID-19 should give me the higher result, then easily you will find out and your paper will not be accepted. So logically, your answer should be correct. You cannot write a program and say milk is black in color. Milk is white in color in India and also in Indonesia. Just because it comes from the black color skinned animal buffalo, you cannot say milk is black in color. Such arguments are not going to be useful. And these are some of the performance measures. You can use the keras of Python and you can get all these. This is another website where you can find out these images. This is the conventional architecture we had. Because of lack of time, I'm just rushing. Maybe if you want to have any idea, you can always contact me offline too. This is the confusion matrix. This is the result. And I want your attention here, right? Don't have any time with 100% result or 1 precision or recall. That is absolutely not possible. I took that result. I had that result, but I did actually some mistakes in my program, some logical mistakes in my program. So when the editor pointed out, when the reviewer pointed out, I changed that and then I got a good result. So don't think 100% is the good result. I need to give that. No, that is not practically. So these are another website where you can contact me. I can give you the other things. You can also check the number of outbreaks and the challenges available. So I'll just finish up with the open research problems. Can you find something equivalent to convolution for feature extraction? Can you replace convolution? How do you fix the number of layers in a custom model? If the job is given to you, can you say that for medical application, let me go for 10 layers, something like that? When executing more images, what happens to computational complexity? This is one of the upcoming area of deep learning. When we talk about more on accuracy, we are missing out on the complexity. Can you do something on complexity? What is your contribution in the model? What is your innovation? And is an accuracy of 100% possible? Right? It may not be possible. If it is possible, just tell me how. And these are some of my special issues which are going on now in IEEE transactions. If you are doing some work on this specific area, you can always let me know. And these are my details. You can note down my email ID, my WhatsApp number. You can visit my webpage too. You can also connect with me in LinkedIn, where I will just announce all my call for special issues. Even now I have announced a few. Maybe if you are good enough, you can go for that too. If you need any support, you can let me know. This is my book depository link where you can get more information on that. Thank you very much for your patience listening. As I told you in the first slide, it is not about how much knowledge you are gaining. More than that, it is all about how much you are going to put in practice. Hopefully, you will put in practice. Let us have a quick question answer session, probably.
Okay, thank you very much, Professor Jude Hemans, for very good presentation. Inspires science to all of us. Hopefully, we can apply it in our scientific research in the field of deep learning and artificial intelligence. Now we are going to the question and answer session. We invite participants to ask to propose question to Professor Jude. There's three question, Prof. Yeah, three question. The first question from Mr. Suhadi. Mr. Suhadi asked about, can computer vision method to detect moving object be combined with machine learning and deep learning? Are the results more accurate? Okay, this is the first question. You can answer one by one, please.
Yeah.
Okay.
The thing is, this is the second question, or
this is the first question
for iris detection?
No, Mr. Suhadi.
Just a minute.
You can look at the chat. Can computer vision methods?
Yeah, I got it. Okay. Can computer vision methods used to detect moving objects be combined with machine learning and deep learning? So moving object detection can be done, right, with computer vision methods such as, say, for example, in transportation systems, intelligent transportation systems, ITS, a moving car, a moving truck. In Indian scenario, the traffic is one of the biggest headache. If you want to move from 10 minutes, it will not be possible because a huge truck or a vehicle will be before you who is not supposed to come there. So how we can identify those things? It is possible with deep learning. There is no meaning in combining your machine learning and deep learning. Don't always combine your machine learning and deep learning. When deep learning is giving you a good accuracy, why should you go for mixing with machine learning? When you are mixing with machine learning, you must have some specific objective on that. If you have some specific objective, then you can mix with machine learning. But deep learning alone can give you the best possible accuracy. You cannot say that when I mix machine learning and deep learning, I will get good results. You cannot say. How can we identify which kernel size is more appropriate for different types of image such as X-ray? Mr. Partho, it is not possible. That's why I told you that the filter size and dimensions, I'm using a flashlight. It is not giving me a correct answer. Then I go out, take another filter dimension. Maybe the intensity is large. Maybe the visual area is huge, right? Till now, till 2021, till this seminar, research is going on. how to fix the dimensions size for a filter, right? But normally, if you choose a filter which is mapping or correlating with the dimensions of your image, then it is good, right? But otherwise, there is no hard and fast rule to choose that this filter will work well for this and this filter will not work for this. Many of the concepts in deep learning are still chosen randomly, right? Maybe you can think about, these are some of the research scope areas. You can explore more on that and try to come with a solution for that. Is DFNN equal to multi-layer perceptron? In architecture wise, DFNN is equal to multi-layer perceptron, but whenever you have the concept or word called as deep learning, right? You cannot say it is completely equal to multi-layer perceptron or MLP. Yes, architecture wise it is fine, but the training algorithm of DFNN is not exactly same as that of your multi-layer perceptron. We have a moment-based algorithm which is normally used. If DFNN is equal to multi-layer perceptron, then there is no necessity for me to say DFNN and MLP, right? I would have plainly straight away, I would have told that it is MLP. The changes in the training algorithm. When we call the network architecture as a deep learning architecture instead of a multi-layer, yeah, it is in terms of the training algorithm. So that's why I gave you the first one. Architecture wise, you may not have much difference. A BPN, you can have 10 layers. Deep neural network also, you can have 10 layers. So when you look at the architecture, you may not have much difference. But what happens is, or the changes are with the training algorithm. So look at the training algorithms, you will have a change. So you cannot call an MLP as a DFN. How 100% possible probability agreement? That is not actually correct, I do not know the name. It is not actually correct. Say for example, I can give you an example. There is a running race for the children, right? One child come to you and he tells you that he got the first position in the running race, right? In the next question you will ask as a parent, if you are a parent, I ask my son and daughter, if I ask them, then immediately they will laugh and say that only 2 people ran the race, right? So 2 people running the race and coming first is not a beauty. So your data set size may be less. I used only 5 images for calculation, and for the 5 images I got good result. So I am saying that 100% it is fine. Or it is something like I am answering only one MCQ, multiple choice question, and answering it correctly, and I am getting the 100%. No, you must validate your system with many images, many data, then automatically your 100% will drop down. 100% is never possible. For iris identification, how can the deep learning do it automatically without feature extraction? Do it due to its process converting from the circular form to, yes. Iris, the shape of the iris is circular, so you can have the rubber sheet transform. You can note down Mr. Eka Nuriando, rubber sheet transformation. Rubber sheet transformation is not feature extraction, right? Don't think it is a feature extraction. It is a process of converting a circular object to a rectangular object, right? So it is not feature extraction. After having the rectangular object, you have the choice. If you are using only machine learning techniques, you can extract features from that. If you are deep learning, straight away give that rectangular object to that. Your question is correct, but that conversion from circular to horizontal is not feature extraction. So still you can do deep learning for iris identification without doing manual feature extraction. Right? So don't think your conversion from circle to horizontal is a feature extraction process. What features you extract? The moments, the mean, standard deviation you extract from the horizontal plate is actually called as the any more questions? Hopefully, if you are not clear, some people who have asked me already, if you are not still clear, maybe you can unmute your mic and let me know, or you can ask Professor Arif so that he can guide me in giving me the answer.
Okay, any other question for the participants? Please. I think it's enough, Professor.
Okay. Thank you very
Okay.
much, participants. It is nice meeting you all virtually, right? Not only this 1 hour session, if you need any support at any point of time, you can always feel free to contact me with my contact. Thank you very much.
Okay. Thank you very much, Professor Jude Hemans, for the excellent presentation. In future, we can share knowledge research experience for the advancement of science that is beneficial for human life on this earth. Okay. Thank you very much. Let's give a big appreciation to Professor Jude Hemans for his scientific contribution in EECSI 2021 conference.
Thank you. Thank you.
Thank you very much. Okay, thank you very much, Prof. Okay, please, just a moment. Wait a moment. We give back to Master of Ceremony. Thank you for the time, Prof.
Thank you very much, Professor Dr. Jude Heman, for sharing knowledge and expertise. And also thank you for Dr. Arif Marwanto for guiding this session. And ladies and gentlemen, now we would like to present token of appreciation to Professor Dr. Jude Heman for sharing his expertise in this session. Please.
Excellent presentation and scientific contribution in the EECSI 2021. Thank you very much.
Thank you. Thank you.
Thank you, Prof. Thank you, Dr. Arif Marwanto.
Okay, ladies and gentlemen, now we will have recess time for a break and preparation for parallel session. After break, we are about to have the parallel session that will be divided into two sessions. For the first session will be held at 12:30 until 14:30. And for information, we will have our third keynote speaker, a young professor, Dr. Luca Di Nunzio from University of Rome, Italy, at 14:30 after the parallel session.
Okay, ladies and gentlemen, I will give a little bit announcement. Now we are about to have the parallel session. The first session will divide it into 5 rooms, and we will take from 12:30 to 14:30. Room 1 will be chaired by Dr. M. Safrullah, and then room 2 will be chaired by Dr. Terry Setiawan. Room 3 will be chaired by Durul Afifah. Room 4 will be chaired by Dr. Munawar, and room 5 will be chaired by Dr. Muhammad Kurhanul Rizki. For presenters, please kindly change your name in Zoom by using the format room code and then underscore full name. So the committee will help you to enter the room. And for the participants, you may choose which presentation room that you intended to join. You can writing in the chat room, so the committee will help you to enter the room. Okay, and please kindly fill up the attendance list which will be given in the chat room by the end of the presentation in each room. Thank you very much for your attention, and we will see you again at 12:30 for the parallel session. Thank you. Okay, during the break time, we will have the montage of EECSI and Unisula. Bapak Ibu yang masih berada di plenary room.
Imam.
Ya Pak Jul.
Oke, memang udah di invite sini ya Pak ya? Betul ya, standby di sini ya berarti.
Halo. Ya Pak Jul, sementara sambil nunggu di ruang utama aja dulu sampai menunggu MC memberikan apa-apa.
Oke, siap.
Good afternoon, everyone, especially for young Professor Dr. Luca Di Nunzio from University of Rome, Tor Vergata, Italy. We are pleased to have you here in the 8th International Conference of Electrical Engineering, Computer Science, and Informatics. As a keynote speaker for the third session, we will start at 14:30, sir. So we'll ask you to wait for a moment because the parallel session is still on progress. Thank you. Ladies and gentlemen, now we are still waiting for the house for the breakout room to deliver the presenters in each room to go to the plenary room again. So as our schedule, we will start the third session of keynote speaker at 14:30.
Semarang is the fifth biggest metropolitan city in Indonesia. It has been continuously growing among its heterogeneous, tolerant, and peaceful social life. Nowadays, Semarang is famous of becoming one of the most considered city for education. One of the pillars of higher education in Semarang is Unisula, Sultan Agung Islamic University. It is one among the universities located in the city. It was established by Sultan Agung Wakaf Foundation in May 20, 1962. Unisula offers a comprehensive Islamic-based educational concept through Islamic academic culture as its education strategy. This is believed to be an educational concept that meets the need for recent education, focusing more on knowledge transfer. During their study in the university, the students are educated to strengthen their Islamic spirit and science and technology through education for Aqidah, worship and moral, through congregational prayer, Islamic dressing, Toharo, exemplary, Islamic hospitality, life quality, strengthening Iqra spirit, developing science and technology based on Islamic values, Islamic learning society, and science and technology appreciation. By generating an excellent, faithful, competitive, and competent generation, this educational breakthrough is expected to be something that can meet the recent challenge. Unisula has various excellent facilities, including having a modern library accredited A, which plays an essential role in the process of building the pillar of Islamic learning society development. As academic main support, the availability of laboratories are significantly needed. Unisula puts great effort to meet the needs and make it as priority to continuously develop. A very representative Islamic boarding house is available for students coming from other cities, especially those majoring in nursery, midwifery, and history of Islamic civilization. Pumanisa Food Court serves the need for students upon food. The cuisines are varied where students can select. This is likewise facilitated with Student Entrepreneurial Center. University Mosque, or popularly recognized as the Mosque of Abu Bakar As-Sagaf. Teaching Hospital, which is integrated with Sultan Agung Islamic Hospital, has become one of the excellent facilities admitted of its excellence in service. To nourish passion and talent of students, Unisula providing various student activity units such as Mapala, Taekwondo, Tarung Derajat, Pencak Silat, Indonesian Red Cross, Islam Practicing Student Activity Units, Art and Culture Group, Menwa, Scout, and many others. Sultan Agung Islamic University has also been actively involved in the community service. One of the endeavor is made by doing collaborative work with the Ministry of Social Indonesian Republic in succeeding 100 Rumah Desa Sejahtera Mandiri program. This program is created to improve the life quality of people around the village through fixing the houses into more livable. As world-class university, Sultan Agung Islamic University has become a choice for students from other countries to pursue their education. Unisula is also proven to be successful in taking their students or graduates to continue their further education in overseas universities. In order to be skillful in international languages, Unisula has also facilitated their students with international language program of selection such English, Arab, and Korean language. In April 2016, students of Unisula gained a remarkable world-class achievement on winning robotic competition held in Trinity College, USA as the general champion by defeating other contestants from China, Israel, US, and some other countries. Unisula is greatly supported by expert lecturers in the fields. Professor is Imam Wahyudi DEA, an expert in the field of water management, is one among many professors working in this university. During his employment, he has contributed to the establishment of the first Delta Center on climate change in Indonesia.
Unisula, Universitas Islam Sultan Agung, now have one center excellent named Delta Center on Climate Change that works on research on Delta area, including coastal area, estuary area, river area as well, and that occur some problem like sea level rise, land subsidence, and climate anomaly. And to support this research, we have some cooperation, especially with Rotterdam University in the Netherlands and University of France.
With all the competitive excellences, it is expected that the graduates will succeed to respond and win the tight competition in this recent global era. fifth biggest metropolitan city in Indonesia. It has been continuously growing among its heterogeneous, tolerant, and peaceful social life. Nowadays, Semarang is famous of becoming one of the most considered city for education. One of the pillars of higher education in Semarang is Unisula, Sultan Agung Islamic University. It is one among the universities located in the city. It was established by Sultan Agung Wakaf Foundation in May 20, 1962. Unisula offers a comprehensive Islamic-based educational concept through Islamic academic culture.
Okay, ladies and gentlemen, welcome back to the main room for the third session of keynote speeches. Now we would like to warmly invite Adjunct Professor Dr. Luca Di Nunzio from University of Rome, Tor Vergata, Italy. This session will be chaired by Dr. Zulfatman, lecturer from Electrical Engineering Department, Universitas Muhammadiyah Malang. I will pass the mic to Dr. Zulfatman. The time is yours.
Thank you very much, Master of Ceremony. Good afternoon for all the participants. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Today we will start our third keynote speaker. Our keynote speaker will be Professor Luca Di Nunzio.
Hello, good evening everyone.
Hello, good evening, Prof.
Good evening to you.
For you now, still morning, okay?
Yes, of course.
So
Yes,
we have to say good morning,
Thank
Prof.
you.
Luca Di Nunzio. Okay. This afternoon, Professor Luca Di Nunzio will be talking about embedded machine learning for the implementation of autonomous mobile sensor nodes. Before he present his keynote speech, let me introduce him. His name is Luca Di Nunzio. Was born in Pescara, Italy, on 23rd April 1979. He received the master degree summa cum laude in electronic engineering and PhD degree in system and technologies for space application from the University of Rome, Tor Vergata, Italy, in 2006 and 2010, respectively. During this period, he has collaborated with several companies in the field of electronics, communication, space, and defense. His main activities regard system modeling and simulation of complex digital system for digital signal processing and their hardware implementation on FPGAs and ASICs. He is an co-author of about 70 Scopus Index research papers. His research activities are in the field of reconfigurable computing, digital communication circuit, digital signal processing, and machine learning. He has been serving as a reviewer for several EEE, MDPI, and Springer Nature journals, and actually he is an associate editor for many international journals, mainly in the field of electronics and computer science. He has been also the organizing committee members of many international conferences during his career. During his career, he collaborates with several international research groups. For example, University of Rome, Tor Vergata, collaborating with the DSP PLSI group coordinated by Professor Giant Carlo Cardaliris Research Group. And DTU, Denmark Technische Universiteit, collaborating with Professor Alberto Nanarelli Research Group. Then the last one, Technical University of EECSI, with Professor Doru Chiep's research group. He is currently an adjunct professor with the Digital Electronics Laboratory at the University of Rome, Tor Vergata, Italy, and an adjunct professor of digital electronics at University Guglielmo Marconi, Italy. Ladies and gentlemen, I think everybody well known about machine learning, but when machine learning embed with autonomous mobile sensor nodes, maybe I think not all of us can understand about this issue. So now Professor Luca Di Nunzio will tell us about how machine learning can embed with autonomous mobile sensor nodes. I think it's a very interesting speech. And now it's time for Professor to deliver the presentation. So now time is yours, Prof.
Thank you for the introduction. Tell me if you can hear me, because the quality of the audio for me is not so good. Sometimes I couldn't hear all your words. I hope you can listen me. Can you confirm?
Yeah, very clear, Prof.
Perfect. So thank you very much for the introduction, and thank you very much for the invitation. Just 1 second, I share my presentation and I start. Okay. Can you confirm me that you see my presentation? Can you see?
Yeah, you can see, Prof.
Okay, perfect. So the title of my presentation is Embedded Machine Learning for the Implementation of Autonomous Mobile Sensor Nodes. Before start with the lecture, a brief summary in where we will see all the issue that we'll discuss in the presentation. So I'll start with the introduction of Autonomous Mobile Sensor Nodes, AMSN. And where we'll see where is very useful use this specific kind of sensor, this specific sensor. And after we analyze the relationship between machine learning, in particular embedded machine learning, and autonomous mobile sensor nodes, we will see that among the machine learning methods presented in the literature, supervised, unsupervised, the reinforcement learning one is the most important for autonomous mobile sensor node. After we analyze a possible scenario in which we analyze the benefit introduced by reinforcement learning, we will consider some implementation aspect, and finally we'll discuss some conclusion. So what is an autonomous mobile sensor node? We can define an autonomous mobile sensor node as a robotic node with sensing and communication capability. So a robot including embedding sensors, actuators, and circuit for communication. For example, rovers used in space mission and space colonization are autonomous mobile sensor nodes. But in general, we can define it AMSN, all robot swarm. This kind of sensor must have some functionalities. Essentially, the main functionalities are three, and are the exploration capability, the recognition, and the data acquisition. For what concerns exploration, the autonomous mobile sensor node must be able to navigate in the environment where it operates. And he must do it using sensor, actuators, and of course other kind of circuit. For what concerns recognition, autonomous mobile sensor node must be able to recognize specific items or specific situation, and in order to do it, they can use, for example, image sensor, radar, LiDAR, and other electronic systems. The last functionality is the capability to acquire data. This means that the AMSN must be able to acquire the quantity of interest using sensor and also using a tether to move and reach the quantity to analyze. Where we need AMSN? Of course, in the exploration of environment that are inaccessible or dangerous for human operators. For example, the space exploration or planets colonization. An example is the colonization of Mars now, or of the moon. But also hostile environment as volcanoes, caves, or emergency situation as, for example, explosion, fire, and accident, that are of course dangerous for human operators. Because an autonomous mobile sensor node is autonomous, the autonomy is the most important feature. And the autonomy introduces the necessity to take decision without the human intervention, or sometimes with a very limited human intervention. Now, if we consider the scenario I told you in the previous slide, we can affirm that autonomous mobile sensor nodes not always are connected with other systems, because not always they are provided with a connection. And sometimes, for example, in space mission or space colonization, because the long distance between the sensor nodes and the human race is impossible a real-time control of the sensor or the sensor swarm. This means that autonomous mobile sensor node sometimes can see as isolated system. They can be isolated for some times, or in general isolated from us, from human. It's obvious that in this scenario, artificial intelligence and, in general, machine learning will play a crucial role. However, machine learning algorithm must be embedded inside the sensor node because, as I told you, sensor node can be isolated. We cannot control them anytime, so machine learning must be embedded inside. This means that the traditional IoT approach based on a global artificial intelligence implemented on remote server is not efficient for this purpose. Autonomous mobile sensor node must be equipped with embedded machine learning. As we know from the literature, there are several machine learning approaches: the supervised learning, the unsupervised learning, and the reinforcement learning. In supervised learning, the system is trained using labeled data. And during the inference phase, the training system produces data output from previous experience. This is the case of classification, regression, and so on. For what concerns unsupervised learning, we can say that during the training, in unsupervised learning, the model is not supervised, and a classical example of unsupervised learning is, of course, the clustering. Reinforcement learning is different because it aims to realize autonomous systems. The learner, that in our case is the autonomous mobile sensor nodes that have to learn, interacts with the environment in which it operates in order to collect information, and it receives an immediate reward for each decision and action it takes. So a very important feature of reinforcement learning is that the agent, that in our case, the agent is the object that learns, that in our case is the autonomous mobile sensor node or a part of the autonomous mobile sensor node. The agent learns directly in the environment where it works. And this feature, we will see, is very useful for autonomous mobile sensor nodes. Of course, inside this kind of sensor node will be present and are present all forms of machine learning, unsupervised, supervised, and also reinforcement. Because, of course, rovers and RoboSwarm has to cluster data, classify data, so they need also supervised and unsupervised learning. However, it's the reinforcement learning that play a crucial role in this scenario, because it has two very important capabilities for this application. The capability to adapt to non-stationary environment and the capability to learn directly on the environment. And these aspects are very important in all this case in which the human control is limited. And AMSN is a typical example of this. So, a brief introduction on reinforcement learning, just a basic introduction. I provide you a paper in the slide if you need more information. Reinforcement learning is based on human learning. In reinforcement learning, we have key characters and key concepts. The key characters are the agent, that in our case is the AMSN, the interpreter, the environment, and the key concepts are action, reward, and state. Reinforcement learning offers two main advantages respect to other forms of machine learning, that are that the dataset is not required. This means that reinforcement learning is not biased by training sets, and the agent adapts itself to any dynamic environment. How works reinforcement learning exactly? We simplify in order to better understand. Take a look to this picture. We have the robot that represents the agent, that in our case represents the autonomous mobile sensor nodes. And we have the environment, that is the place where the agent operates. Space colonization, volcanoes, caves. The agent initially finds itself into a state and starts to perform action, casual action in the environment. At this point, the interpreter analyzes the action of the agent. If the action is good to accomplish the purpose of the agent, the interpreter provides a good reward to the agent. If the action of the agent is bad, there is a sort of punishment. The interpreter provides a bad reward to the agent. This process is iterative, and after several iterations that depend by the application, the system, the environment, the agent learns to act correctly in the environment. The literature offers several Q-learning algorithms. Among all these Q-learning algorithms, the most famous is the Q-learning among the reinforcement learning algorithm, presented in the 89 by Watkins Cambridge of the University of Watkins of the University of Cambridge. In Q-learning, the quality of the action are mapped into a Q matrix called also Q table. The Q matrix is organized in row and column. In the row, we have the possible state in which the agent can stay, and is labeled with N. In the columns, we have all the possible action that the agent can perform, and the action are labeled with Z. At any iteration, the Q table is upgraded using this mathematical relationship. I provide you the link to the original work of Watkins. So at an iteration, there is the upgrade of the matrix using this relation that for us is not important now. We have just to understand that it is an iterative process, and at any iteration, there is the upgrading of the matrix. When the learning is finished, the value of the Q matrix are more or less stable. So if we analyze the matrix at any iteration, we can see that the system finished the learning phase when the value of the Q matrix are more or less stable. Now, we'll take a look to a possible real scenario. We will see that using reinforcement learning in a real scenario is it possible obtain very important capability, very important innovation? In particular, we consider the near future communication scenario for planet exploration proposed by the European Space Agency. In this scenario, as the name suggests, is for planet exploration and also in part for planet exploration, colonization. So we have in this case, this is Mars, but we can extend this concept to any planet. We have the planet Earth here. We are here now. And we communicate with Mars using several types of orbiter. There are science orbiter, communication relay orbiters, but for now are important, for us now are important just the communication relay orbiters. These orbiter make possible the connection with all the autonomous mobile sensor nodes that in this case are rovers and mobile probes. In this scenario, there are two important aspects that reinforcement learning could provide, that are the autonomous learning and the experience sharing. For what concerns autonomous learning, in this scenario proposed by European Space Agency, communication standard change over time for several reasons. Change in function of the quality of communication channel, can be upgraded during the years, and so on. There are many reasons for which the communication standard change. This means that all the rovers, all the autonomous mobile sensor node must automatically identify the communication and adapt itself to the communication. In addition, because all these elements have to collaborate each other, it's very important that they can share what they learn. So the experience sharing is a crucial aspect. And we will see that using reinforcement learning, this system can get autonomous learning and experience sharing feature. So we'll start with an example of autonomous learning. And for this example, we consider communication issue that AMSN have to deal in this scenario. In this kind of mission, the sensor has to detect the radio emission. So he had to find the carrier frequency, estimate the level of the signal. After, it has to identify the transmission scheme in terms of symbol rate, modulation types, and so on. And once is identified, the modulation scheme, the system has to transmit and receive data to the orbiter, but in some cases also to other rover that communicates directly with him. Now, this is just an example because this scenario is very complex. There are many things to do, but we will see that, for example, using reinforcement learning, embedding reinforcement learning inside the sensor node, is it possible to realize a flexible timing recover, able to adapt itself to the modulation scheme. So, a simple digital receiver, we are simplifying, is composed of three main blocks that are the carrier recovery, that as the name suggests is used for recovery the carrier, the timing recovery, and the symbol decoder. Now for this example, we analyze just the timing recovery. Usually, timing recovery are implemented using specific circuit as, for example, the Early-Led circuits, the Gardner circuits, and the Müller-Müller circuit. This kind of circuit depends by the modulation scheme and the environment. So they cannot adapt themselves to dynamic environment. What is the scope of the timing recovery? The scope of the timing recovery is a sample the received signal at the center of the A diagram, as this picture suggests. We present a work on IEEE access Hello? Can you still hear me?
Okay, okay, you can see, Prof.
Ah, okay, perfect. Okay, so we presented a paper on IEEE Access in which we show that using reinforcement learning, embedding reinforcement learning inside the system, is it possible create timing recovery circuit able to adapt themselves to any kind of situation, learning directly from the signal that they analyze. This is the block diagram of the system that we propose, that essentially is composed by an interpreter, that is the core of the system, a Q-learning engine, and a sampler. How work this system based on reinforcement learning? Work in this way. The system analyzes the blue dotted signal, that is the received signal. And analyzing the signal, he must understand where undersample this system. So the system tries to sample in a casual way and perform its operation. At this point, the interpreter analyzes the quality of the work performed by the agent, considering the variance of the signal sampled, because of course we have a big variance, the quality of the work is bad and the reward will be bad. But if we have a short variance, the quality of the work is good and the interpreter will provide a very good reward to the Q-learning engine. We implement this system in MATLAB and Simulink and after on FPGA, and we test this system on real hardware. And for what concerns the performance, communication performance, we can say that the bit error rate is comparable with traditional time recovery circuit, but different from traditional timing recovery circuit. The proposed timing recovery system based on reinforcement learning has the capability to adapt itself to different modulation. So if the modulation scheme change, the sensor node adapts itself to the new modulation. So, as I told you, using reinforcement learning, we provide the capability of autonomous learning that traditional methods cannot provide. The other important feature that can be obtained using reinforcement learning is the experience of the sharing. This is true for swarm system composed with more than one rover, more than one sensor node. In this context, the context of the space exploration, if the rovers can learn one from each other, we have two main advantages. The first one is that the autonomous mobile sensor node is able to learn without the human intervention. This is very important in this context. The second one is that the learning time of the swarm is reduced. Consequently, the swarm of autonomous mobile sensor node can accomplish the scope, its work, in few time. But how is possible provide experience sharing to autonomous mobile sensor nodes? The answer is using multi-agent reinforcement learning, embedding inside this node the multi-agent reinforcement learning algorithm. In the last years, literature offer several new multi-agent reinforcement learning. 2 years ago, on electronics later, we proposed the QRTS. QRTS is a multi-agent reinforcement learning that we test in a traditional problem of maze solving. In this figure, in these maze, each cell represents a state in which the agent can stay. And for any cell, there is only one correct choice that is represented with the blue arrow. This means that the only possible solution relative to one cell is the direction of the blue arrow. All these arrows are available only after the algorithm convergence, so only at the end of the learning phase. We show that using QRST and use more agent, so using, in our case, more autonomous mobile sensor node, thanks the feature of sharing, thanks to the capability to share the experience, the convergence speed, the learning speed of the swarm is accelerated. This means that if we imagine to have more than one rover in a scenario, the learning time can be reduced using this approach. Essentially, we provide this capability introducing two Q metrics. A local Q matrix that is equipped inside any agent, and a global Q matrix that observe what happens inside the agents and manage this agent. The global matrix is updated considering the contribution of all the local matrices, and the local matrix is updated considering what happens in the global matrix. The algorithm is very robust because in case of missing of one agent, the system continues to work, and the not connected autonomous mobile sensor node is capable to work using standard Q-learning instead of QRLTS. We test this algorithm in several modes, and I show you just one result. We can see that in the case of a single agent, we have that the system is stable after a certain number of iterations that ends when the blue line becomes flat here. But if we increase the number of agents, so the number of autonomous mobile sensor nodes, we obtain a reduction of the learning time. So, as I told you, thank you to the experience sharing feature introduced by this specific kind of reinforcement learning, we improve the performance of the system because the entire swarm is capable to learn in few time with respect to the single agent. So all the system must be implemented, must be embedded, must be hardware implemented inside the mobile sensor node. And in this scenario, there are two critical issues, two critical requirements. The first one is that multi-agent reinforcement learning and in general machine learning system can involve complex computation. They sometimes require high computation capability. So not always it's possible to use microprocessor because they are very slow. And we have three possible solutions that are the ASIC, the FPGA, and the GPU. ASIC offer the best performance in terms of power, speed, but they are not flexible and are not the good choice for this scenario because they cannot be reconfigured, of course. To the other hand, FPGA have present a good compromise between computational capability and flexibility. They probably are the best choice, also because GPU are not so efficient in this context because they are efficient only for themed operations. So probably they are efficient for neural network, convolutional neural network, but they are not so efficient for multi-agent reinforcement learning that is not based on matrix computation, so it's not based on sim operation. The other important aspect that must be considered during the implementation is that the system have to be characterized by a limited power consumption because the EMSN are not connected to the power grid usually. And if we analyze this aspect, we can see that also in this case FPGA is the best choice. ASIC of course are better in terms of power consumption, but they cannot be reconfigured. But FPGA offers good performance too in terms of power consumption, also because modern FPGA offer during the implementation also clock gating, power gating capability that allows to reduce power and dynamic power consumption. That, as I told you, is a very important aspect. Okay, FPGA is the best choice, but there is a problem today that machine learning system, multi-agent reinforcement system are complex. So it's very difficult to describe this system using traditional RTL flow based on HDL language. because the time required for the development could be very long. The develop time is very long because, as you know, HDL language are very complex. They are more complex than programming language. This means that we can have problem both in the design and in the verification. But for what concerns verification, the using of UVM methodology probably solve the problem because will allow us to verify the system in few time. The problem remains the design. What about the design? FPGA vendor know that it's very difficult to implement multi-agent reinforcement learning and machine learning system inside FPGA because their description in VHDL or in System Verilog will require too much time. For this reason, FPGA vendor and other companies are creating new tool for the implementation of embedded machine learning. For example, Xilinx proposed the VTIS artificial intelligence tool. This is a very powerful tool, but the user, the designer, has few control on the resulting RTL architecture because essentially this tool instantiates specific architecture for machine learning and designer don't have too much control on this instantiation. And a similar problem is for the MATLAB Simulink HDL coder for machine learning. It is a tool that allows to generate automatically the HDL or System Verilog starting from a Simulink block diagram. Also in this case, the designer has full control on the final RTL architecture. Intel proposed a flow based on the OpenCL language. So designer could describe in OpenCL the machine learning architecture and the tool converted OpenCL in VHDL or System Verilog. However, also this flow presents two main limitations. The first one is that OpenCL is efficient for SIMD architecture, so probably is efficient for CNN and in general neural network, but not for reinforcement learning. The other problem of this approach is that only a reduced set of OpenCL command can be synthesizable can be transformed in VHDL and can be synthesized by the synthesizer. So the last interesting tool that I will discuss is the Xilinx HLS. Xilinx HLS is a software that allows to automatically transform C and C++ code in VHDL or Verilog or System Verilog. This is very interesting. However, nowadays results are not so optimized in terms of hardware results and power if compared with the VHDL the script that wrote by hand by the designer. So to conclude, embedded machine learning, in particular reinforcement learning, play and will play always more crucial role for autonomous mobile sensor node. This is because it offers interesting features, as for example, the capacity to learn autonomously without human intervention, and also the capability to share experience among the sensor nodes. In this context, FPGA will play a crucial role because they probably are the best architecture for the implementation of machine learning and reinforcement learning algorithm, offering flexibility and high computational capability. However, today it's not so easy use FPGA in an efficient way in this context. So probably we need some years to be able to describe, implement on FPGA in a very efficient way in order to limit power consumption, hardware resource, machine learning algorithm. Because the traditional techniques based on HDL design requires too much time for the development. So I think that in order to use FPGA in a very efficient way, we have to work that FPGA designer provide and improve their specific for machine learning. Okay, it is all. I thank you for the attention, and thank you very much.
Okay, thank you very much, Professor Luca Di Nunzio, for your presentations. It's a very interesting topic when the presentation trying to combine between machine learning then apply to autonomous mobile sensor nodes. I think it's one of very interesting things that will be developed for I think for the future. But now we have around 15 minutes to question and answer. I think the participants already has some question, and then we try to give you 2 questions for the first section. Okay, now we have 2 questions first from the audience. You can ask directly or just write down in the chat column.
So I have to analyze the chat. Okay. Yeah.
Still no question, Prof. In the.
Yes. Okay. I'm reading. I have to write the answer, or I have to discuss here.
Yeah. The question is can ask directly, or write the question in the chat, and then you can then we can discuss directly.
Okay, so I see 2 questions. The first one is, dear Professor Di Nunzio, can the reinforcement learning not only reconfigure the time synchronization data, but how about reconfigure the fault in sensor, such as missing data, lack of measurement, and randomly data and saturation? Yes, this is a very important question. This is a very important issue that must be analyzed. Of course, reinforcement learning, I present reinforcement learning providing example in particular about communication, but reinforcement learning can be used, for example, only to correct some problems of electronic device, because probably is a good method, for example, to mitigate some non-ideality of component, of electronics component. And I think that it will be used especially to mitigate the effect of time on electronics device, because if we observe the system, if we analyze the system, and we can understand that one component is changing over time, analyzing the output of the systems, and with reinforcement learning, for example, we can mitigate the effect of time on component, analyzing what is happening and providing a bad or a good reward to the systems. The second question is how communicate swarm in FPGA without rows. For rows, what are you intend? A real-time operating system or what? Because it's an acronym also very used. I don't know, Willy, what you intend for ROS.
Hello?
Can you listen to me?
Yeah.
I cannot listen you. Robotic operation system.
Oh, I think the participant asked directly to your chat, so, because not appear in our chat. Okay.
Sorry? I don't understand you. Can you repeat, please?
Yeah, I think the participant asks directly to your chat, not for for everyone.
Okay.
Yeah, I think so. No, so it's not appear here.
Okay, in general, communication of Word can be provided also using specific circuit that does not require, for example, operating system and so on. And in addition, on modern FPGA, it's also possible to implement soft microprocessor, and sometimes they present also hard microprocessor. So I think that in general, we can imagine that the architecture of the future will be an FPGA in which there is a microprocessor, probably a soft microprocessor, as for example Microblaze of Xilinx or Nios 2 of Intel, and this microprocessor perform all the slow operation. For example, manage the ADC, the digital analog converter, and for example, manage other specific circuit as a sensor and so on. And this microprocessor will be connected with an hardware accelerator implemented on the FPGA that perform just as machine learning or reinforcement learning accelerator. So the system inside the FPGA chip, we will be a microprocessor in which we can also implement, for example, a Linux kernel or in general operating systems, and a specific hardware accelerator implementing machine learning and multi-agent reinforcement learning operation. Okay, I hope... okay, you're welcome. I don't know if there are other questions.
Yeah.
Okay.
Another one. Another one from Arif Marwanto.
Okay, give me 1 minute to read it.
Okay.
Okay, to apply and analyze data by using machine learning from an autonomous sensor, how much bigger the data that provided by the autonomous sensor? The problem autonomous mobile is only provided by mobile phone, prof. I don't, okay, how much bigger? The problem automobile is only okay. This scenario is very complex. I want to ask to IF, that is the people that perform provide the hardware, to if he can better explain me what's intended for how much bigger the data that provided by the autonomous sensor. If you can write, because I don't understand in deep your questions.
Okay, well, my question is about how much.
I don't listen very well. If you write, it's better, because the quality of my audio is not so good.
Okay, I write in chat there.
Oh, yeah.
Okay.
It's clear. It's clear now.
It's clear, is it clear, my voice?
It's clear.
No, your voice, yes, now it's clear.
Okay. My question is, if we have to apply the machine learning, yeah, in autonomous sensor. So today, the autonomous sensor is only provided by mobile phone, such as humidity, temperature, and GPS, and all, etc. So, how much bigger if we want to analyze the data, yeah, using machine learning? How much bigger? how big we have to provide. How much, for example, it's 1,000 data or 1,000,000 data or something like this.
Depends by the application, depends by the machine learning methods that we have to use. It's not easy answer in general to these questions, because depends by several aspects that must be considered in this context, of course.
Yeah, that's our problem. So our problem is because our limitation of the mobile sensor and the collected data is very gathering data is the most problem. Yeah, because if we want to collect the data, we have to take it from the telecommunication provider. Okay. Thank you, Prof.
You're welcome.
Okay. Thank you.
Okay, please have about 5 minutes more for the Q&A. Please, any more question? Maybe I have one question, Prof. I think regarding limitation of agents can connect to the
Sorry, limitation of?
Agents, number of agents.
Depends. Also in this case, depends by the application. Theoretically, there is not a limitation in terms of number of agents, but in the reality there is, for several reasons. Because if we have too much agent, we can have too much access to the channel communication. We can need to, there can be also another problem, that if we have too much agents, if we use, for example, QRTS, that is the algorithm that I propose, that we propose in the literature, the global matrix could be too much complex to upgrade, and so there could be some limitation in terms of computation, because the hardware can be not sufficient for perform of the operation. But in general, depends also by the application that the system is performing, the scope of the payload of the sensor node. In general, we can imagine that we can manage without problem more or less 100, but it depends by the application. Is just a number. It's not possible give an exact number of the number of nodes that can be involved in the swarm using this approach.
Yeah, the questions because we use FPGA. I think there is a limitation FPGA in terms of how fast it can be go computationally and power consumption. But
you use FPGA for a single agent, or you implement all the agent inside the same FPGA? Because in some application, all the agents are in the same hardware. Of course, in the application that I present today, no, because every rover has a specific hardware. But in your case,
no, I have implemented in FPGA yet, but I just asked the limitation of agents regarding the limitation of FPGAs. So, for example, 2 agents or 3 agents, I think, you has already answered this question actually.
Okay, modern FPGA offer very could be also very large. If you consider the best device of Xilinx, for example, they are very big in terms of logic blocks and also DSP blocks. So using last generation FPGA, you can implement very complex system of multi-agent machine reinforcement learning without problem. some problems. You can have some problems on traditional machine learning, for example, CNN, because if the number of stage of the CNN is very high, of course you have to serialize some operation, and you can have some limitation in terms of processing time, but in general your performance will be always better of a microprocessor or GPU, of course.
Okay, I think our time's up, Professor and the participant. I think that's all for our discussion and our section this afternoon. Thank you very much, Prof.
Thank you all. Thank you.
It's a very interesting topic you have already delivered this afternoon for us. And I think participants, I think that's all for our discussion in this section. And then after this, we can continue for the follow section. That's all. Thank you very much for the professor. See you again, and good afternoon.
Good afternoon. See you. Bye bye.
Thank you.
Okay, thank you very much, Adjunct Professor Dr. Luca Dinunzio, for sharing knowledge and expertise. And also thank you, Dr. Zulfatman, for guiding this session. Now, we would like to present token of appreciation to Adjunct Professor Dr. Luca Dinunzio for sharing his expertise in this session.
Ladies and gentlemen, here is the certificate of appreciation for Adjunct Professor Dr. Luca Dinunzio. Please give applause for both Dr. Luca Dinunzio and Dr. Zulfatman. Ladies and gentlemen, now we will continue the second parallel edition of EECSI 2021. So the host of each parallel room will ask you to join to the breakout room again, or you may ask to the committee to join in a certain parallel room by writing down in the chat room. Okay, and by the end of the session, please kindly join again in the main room for having announcement of best papers and closing ceremony. Thank you. For host of each parallel room, you may start to ask the presenters to join in each room, and then the moderator will continue the second session of this parallel presentation in this afternoon.
Semarang is the fifth biggest metropolitan city in Indonesia. It has been continuously growing among its heterogeneous, tolerant, and peaceful social life. Nowadays, Semarang is famous of becoming one of the most considered city for education. One of the pillars of higher education in Semarang is Unisula, Sultan Agung Islamic University. It is one among the universities located in the city. It was established by Sultan Agung Wakaf Foundation in May 20, 1962. Unisula offers a comprehensive Islamic-based educational concept through Islamic academic culture as its education strategy. This is believed to be an educational concept that meets the need for recent education, focusing more on knowledge transfer. During their study in the university, the students are educated to strengthen their Islamic spirit and science and technology through education for Aqidah, worship and moral, through congregational prayer, Islamic dressing, Toharo, exemplary, Islamic hospitality, life quality, strengthening Iqra spirit, developing science and technology based on Islamic values, Islamic learning society, and science and technology appreciation. By generating an excellent, faithful, competitive, and competent generation, this educational breakthrough is expected to be something that can meet the recent challenge. Unisula has various excellent facilities, including having a modern library accredited A, which plays an essential role in the process of building the pillar of Islamic learning society development. As academic main support, the availability of laboratories are significantly needed. Unisula puts great effort to meet the needs and make it as priority to continuously develop. A very representative Islamic boarding house is available for students coming from other cities, especially those majoring in nursery, midwifery, and history of Islamic civilization. Umanisa Food Court serves the need for students upon food. The cuisines are varied where students can select. This is likewise facilitated with Student Entrepreneurial Center. University Mosque, or popularly recognized as the Mosque of Abu Bakar As-Sagaf. Teaching Hospital, which is integrated with Sultan Agung Islamic Hospital, has become one of the excellent facilities admitted of its excellence in service. To nourish passion and talent of students, Unisula providing various student activity units such as Mapala, Taekwondo, Tarung Derajat, Pencak Silat, Indonesian Red Cross, Islam Practicing Student Activity Units, Art and Culture Group, Menwa, Scout, and many others. Sultan Agung Islamic University has also been actively involved in the community service. One of the endeavor is made by doing collaborative work with the Ministry of Social Indonesian Republic in succeeding 100 Rumah Desa Sejahtera Mandiri program. This program is created to improve the life quality of people around the village through fixing the houses into more livable. As world-class university, Sultan Agung Islamic University has become a choice for students from other countries to pursue their education. Unisula is also proven to be successful in taking their students or graduates to continue their further education in overseas universities. In order to be skillful in international languages, Unisula has also facilitated their students with international language program of selection such English, Arab, and Korean language. In April 2016, students of Unisula gained a remarkable world-class achievement on winning robotic competition held in Trinity College, USA as the general champion by defeating other contestants from China, Israel, US, and some other countries. Unisula is greatly supported by expert lecturers in the fields. Professor is Imam Wahyudi DEA, an expert in the field of water management, is one among many professors working in this university. During his employment, he has contributed to the establishment of the first Delta Center on climate change in Indonesia.
Unisula, Universitas Islam Sultan Agung, now have one center excellence named Delta Center on Climate Change that works on research on delta area, including coastal area, estuary area, river area as well, and that occur some problem like sea level rise, land subsidence, and climate anomaly. And to support this research, we have some cooperation, especially with Rotterdam University in the Netherlands and University of France.
With all the competitive excellences, it is expected that the graduates will succeed to respond and win the tight competition in this recent global era. Semarang is the fifth biggest metropolitan city in Indonesia. It has been continuously growing among its heterogeneous, tolerant, and peaceful social life. Nowadays, Semarang is famous of becoming one of the most considered city for education. One of the pillars of higher education in Semarang is Unisula, Sultan Agung Islamic University. It is one among the universities located in the city. It was established by Sultan Agung Wakaf Foundation in May 20, 1962. Unisula offers a comprehensive Islamic-based educational concept through Islamic academic culture as its education strategy. This is believed to be an educational concept that meets the need for recent education, focusing more on knowledge transfer. During their study in the university, The students are educated to strengthen their Islamic spirit and science and technology through education for Aqidah, worship and moral, through congregational prayer, Islamic dressing, Toharo, exemplary, Islamic hospitality, life quality, strengthening Iqra spirit, developing
Okay, ladies and gentlemen, the whole agenda of the conference today is coming to the end. Now it's time for announcing the best papers. And gentlemen, please join me to welcome Indonesia Country of Institute of Advanced Engineering and Science, IAES. To announcing the best paper, please welcome Dr. Munawar Agus Riyadi.
Okay, thank you to Master of Ceremony. Dear all distinguished guests, authors, and participants of EECSI 2020, first of all, we would like to share our gratitude and appreciation for all of your great presentation and contribution to this conference for the whole day. We have learned a lot and gained new knowledge from the invited speakers and for the presentation as well. Thank you very much. And now we're almost in the end of the conference, and the conference will be closed officially soon. But before that, we would like to announce several important things. For the first, we would like to announce the Best Paper Awards. The TPC, the technical the TPC team have decided to select several papers for the Best Paper Awards. Additional certificate will be presented to the authors of the Best Paper Awards. And the award goes to, the first one goes to Muhammad Fauzan Ridha and Irwan for the paper entitled Strawberry Fruit Quality Assessment for Harvesting Robot Using LSD Convolutional Neural Network. And the second goes to Idawu Iselwa Ajayi, Yahya Mejahdi, Lina Murah, and Fatima Kadur, sorry for the spelling, for the paper entitled Physical Layer Security by Interleaving and Diversity, Impact of Imperfect Channel State Information. And the third goes to Romeo Guiliano for the paper entitled The Next Generation Network in 2030, Application, Services, and Enabling Technologies. And the fourth goes to M. Agus Syamsul Arifin, Susanto Juli Recito, Muhammad Yazid Idris, and Rahmat Budiarto for the paper entitled Denial of Service Attacks Detection on SCADA Network, IEC 608705104 using machine learning. The next award goes to Muntasir Rafiq, Abdullah Alawi, Adnan Farhat, and Muhammad Kausar for the paper entitled Suitability of FPS and GPS in NOMA for Real-Time and Non-Real-Time Applications. Okay, the next one is for Parto Gose, Uzal Kumar Charje, Muhammad Abdul Islam, Salima Sharmin, and Muhammad Ashrafuddin for the paper entitled Deep Viewing for COVID-19 Detection from X-ray using CNN-based architecture. And the last one is for Agus Adi Nugroho, Muhammad Khoshin, Bustanul Arifin, Muhammad Hadin, Baktiudos Prapto, and Zainuddin Nawawi for the paper entitled Load Effect on Switch Reluctance Motor using Hysteresis Current and Voltage Control. Okay, congratulations for all winners. And the second announcement is about the IEEE Explore. Our conference has been knowledge and has been in cooperation with IEEE for technical cooperation, and all the papers will go to IEEE Explore, but as required by IEEE, all papers have to be presented in the conference to be submitted for inclusion in IEEE Explore. So moreover, all the papers should meet the required quality for successful inclusion in Explore. Therefore, generally, please send the final version of your paper before or at 25 October 2020 for the final proceeding of the EECSI, and please use the IEEE template accordingly. And the third announcement is about certificates. Our certificate will be sent to the authors by email within 2 days. Hopefully, tomorrow will be sent to all presenters. And lastly, extension to journal. Several authors has asked about the extension to journal. Selected papers will be invited to our journal partners. The selected papers will be contacted directly by the journal. And that's all again on behalf of the Technical Program Committee of EECSI 2001. Thank you for the successful conference today. The special appreciation goes to the reviewers, all the organizing committees, backroom staffs, and also Unisula as the host of EECSI 2021. And see you in the next chapter of EECSI. Thank you very much. Thank you very much, and I pass the screen to the MC. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you, Dr. Munawar Agustiadi, for announcing the best paper, and congratulations to the presenters who achieved the best paper predicate. Thank you.
Ladies and gentlemen, now please join me to welcome Dean of Faculty of Industrial Technology Unisula, Dr. Novi Marliana, to give closing remarks. Please welcome Dr. Novi Marliana.
Okay, thank you for the time. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In the name of Allah, the most beneficent, the most merciful, our Honorable Rector of Unisula, IEEE Indonesia, IAES Indonesian Country Manager, Keynote Speaker, and General Chair. Our Honorable, all the participants who joining the 8th International Conference on Electrical Engineering, Computer Science and Informatics, EECSI 2021. Good evening, ladies and gentlemen. It's an honor for me to speak as the Dean of Faculty of Industrial Technology, Universitas Islam Sultan Agung. We are pleased to be the host of the EECSI 2021. It's the second time for our faculty has hosted this conference. The first was in 2016. Thank you for this prestigious opportunity. We would like to express our highly appreciation to the keynote speakers, presenters, participants for attending, sharing, and presenting the ideas and experience in this interesting conference. And also, we would like to thank to the committee and all the collaborators for the organizing this conference and ensuring it runs so smoothly. We do hope that this conference will encourage another collaboration among us next year in the future. We would like to apologize for any inconvenience that you might experience during this conference. The last, we also congratulate for the winners of the best paper of EECSI 2021. Congratulations. Once again, we would like to say thank you for your active participation. Good luck and stay healthy. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mrs. Dean.
To express our great appreciation for all main organizers, collaborators, sponsorships, committee, participants, and presenters here. Thank you very much for your participation. I hope this conference will be very beneficial for all of us, and see you in the next agenda of EECSI. Stay safe, stay healthy, and always be happy.
Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you.
Thank you.
Thank you very much.
Thank you for all.
Semarang is the fifth biggest metropolitan city in Indonesia. It has been continuously growing among its heterogeneous, tolerant, and peaceful social life. Nowadays, Semarang is famous of becoming one of the most considered city for education. One of the pillars of higher education in Semarang is